Millions of years ago, Saturn has an extra moon. Perhaps 400 kilometers across and formed almost entirely of ice. But this moon is doomed. It's orbiting just too close to resist the immense forces of Saturn's gravity.
The rings probably formed from an object that got too close to Saturn. There's this invisible boundary around Saturn called the Roche limit, and that's the limit, depending on what you're made of, where Saturn's gravity is strong enough it will actually pull you apart, that the gravity on the side closer to Saturn is strong enough that, compared to the gravity on the other side, that will literally rip you apart. You don't have enough gravity of your own to stay together.
A leading theory suggests that just beyond Saturn's atmosphere, an ice moon approaches close to or even just inside its Roche limit. As Saturn's immense gravitational force pulls it apart, the moon begins to rupture catastrophically. A world ripped apart by its proximity to a giant. Up to 17,000 trillion tons of ice breaks apart in orbit around Saturn. And thanks to the speeds this material is traveling, it's likely that in just a few days, it spreads out to encircle the great giant. Saturn's iconic ring is now in place. But as Cassini turns its instruments towards it, it sees a single ring, transformed.
The images we returned, they were phenomenal. They were resolution factor of maybe 20 times better than anything we had had before.
Cassini reveals how Saturn's giant rings have evolved. This debris now forms a disk wider than Jupiter, yet on average, just 10 meters thick. Within, moon-sized chunks of ice orbit the structure, clearing great voids, turning one ring into many. But it's as Cassini captures images with the sun directly above the equator that the most surprising feature of the rings emerges.
We knew this was going to be a time for us to investigate the third dimension, something that you don't get to see when you just look at a picture of Saturn's rings. And what we found was staggering. Just right out of the gate, we saw vertical structures. I just can't tell you how surprised we were to see this. It's just the spectacle of it was just unanticipated. I have just imagined flying along in a shuttlecraft across the ring, right, close to the ring. So to my perspective, it would be almost like it was an infinite sheet of gleaming debris. And I'm flying along and flying along and flying along, and suddenly I come upon a wall of rubble that's 2 miles high. I mean, is that cool or what? Really, I've said over and over again, they should put that in a movie.
This once tiny world of rock and ice that has seen the most dramatic transformations is today the solar system's greatest jewel. After more than a decade in orbit, Cassini has forever deepened our understanding of Saturn. But its mission is far from over.
The Earth is speeding up. It's literally spinning faster. Could it cause a tech meltdown? And what have melting glaciers got to do with it? You may or may not know, I mean, I wouldn't expect you to know, there are 86,160 seconds in a day. But scientists who measure time have found that in 2021, the average day is 0.05 milliseconds less than this. That's because the Earth is literally speeding up. Okay, so you might think 0.05 milliseconds, so what? But this actually goes against everything that we expect to see happen, and scientists are desperately trying to find an answer. Because since its creation, Earth's spin has actually been getting slower. In a not very recent history, the days on Earth used to be twice as fast. But what does a faster spinning Earth actually mean? 3.5 billion years ago, the planet's rotation used to be only 12 hours long. At that kind of pace, life would really suck. We'd have nightmarish weather patterns, with hurricanes tearing across the land. Centrifugal force would pull water towards the equator, flooding entire regions like Indonesia and the northern tip of South America. Okay, that's a worst case scenario, and Earth is unlikely to ever spin that fast again. But if we keep speeding up, it could be bad in another way. By 2030, there could be a full-scale technological meltdown. GPS relies on precision timing, and if a day falls too far behind that 24-hour benchmark, there could be disastrous consequences. For one, satellites could lose their correct place in the atmosphere, and we'd lose all means of being able to predict where they are in the sky. If we leave this slip for too long without correcting it, then our navigation systems will be completely wrong, throwing all of our smart technology off course. Fortunately for us, we can sidestep this disaster, and there's a fairly easy workaround. Timekeepers can add and take away what's known as leap seconds to account for these tiny differences. They can alter what's known as international atomic time, which can be adjusted for the subtle discrepancies between the Earth's rotation and our clocks. And what's pretty mind-blowing is that by observing the night sky, we can keep track of these tiny changes. So keeping time is a pretty skilled art form. That's how we know that the Earth is spinning faster. But that doesn't explain why, despite billions of years of slowing down, the Earth's rotation is speeding up. So what's causing it? This is Dr. Jazz Hill-Valler. She's an expert in how the climate affects the Earth's rotation.
So we probably all know that the melting ice caps is going to cause sea levels to rise. Well, it's also causing the Earth to spin faster. And what happens when the Earth spins faster is that we get a greater centrifugal force. Imagine a figure skater. When you watch figure skaters, they start off spinning really slow with their arms out, and as they bring their arms in, they start to turn faster and faster. That's because they're bringing more mass towards the center of their rotation. So how can that happen on the Earth? Well, water has this crazy property where when it freezes, it actually expands. So if you think about all of the glaciers and the mountains and the ice sheets as being these huge, tall, towering sheets of ice, well, what would happen if we suddenly melted them really quickly, which is something that we're seeing happening at the moment? If we take all of that mass in those glaciers and those ice sheets and suddenly it melts and gets closer and closer to the surface, just like the figure skater bringing their arms in, all of that mass is going towards the center of rotation, meaning that the Earth is going to start spinning faster.
This meltwater currently sits at the poles. This is why right now scientists believe the Earth is spinning faster than usual. So will it get faster forever? Here's the conundrum. Actually, scientists expect this to be just a blip. Although it's been getting faster for the last 2 years, experts expect the Earth to go back to its longer-term pattern of slowing down. And it's the Moon that's causing this.
This is to do with the tidal relationship between the Moon and the Earth. We only see one face of the Moon. It's tidally locked with the Earth. So as the Earth is turning, the Moon is pulling the ocean towards it, and then as we move away, the oceans go back round, and that causes our tides. So this kind of wobbly dance between the Moon and the Earth means that the Moon is slowing down the Earth, and all that energy that's lost from the Earth slowing in its rotation is getting put into the Moon's orbit, and the Moon is actually moving further away.
As it continues to drift away, the effect of the Moon's gravity on Earth weakens, causing us in the longer term to slow down. What's more, over time, the melted water in the polar regions could actually make the Earth spin slower. Some scientists believe that the water will drift towards the equator, which will further slow down the Earth's rotation. This is called equatorial bulging. Think of it as a big spare tyre around the middle of the Earth. It exists already down to the centrifugal force exerted on the ocean by Earth's rotation. But adding to the weight of this tyre is no good thing.
All of that excess water is going to go and sit around the equator, which means that there's more mass further out from the centre of rotation. The equatorial bulge of water is going to get higher, which means that around the equator there's going to be even higher sea levels than we originally predicted. It could mean that hurricanes and typhoons and cyclones that form at the equator could become more severe because there's more water vapor there. So the increased severity of these storms because of the Earth spinning faster is probably only going to be a temporary effect, but that doesn't mean we shouldn't be worried about it, because more severe storms means that we're going to see more severe natural disasters happening all over the planet.
So although at first glance it doesn't seem that important that the Earth is spinning a bit faster, it really does matter, because it could be a big hint as to what else the climate crisis has in store.
We lost comm with the spacecraft.
If the spacecraft wasn't back up and running by the time we flew past Pluto, our 9-year wait would have been for nothing.
There's a little bit of drama because this is true exploration. New Horizons is flying into the unknown.
When we got there, we saw something that absolutely blew our minds. It was incredible. When we saw these photographs of what it actually looked like, really a world in its own right, it was mind-blowing. There was active geology on Pluto right now. Something so far from the sun should just be a cold, dead world, but it's not. It had this living, breathing heart.
3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft in a decade.
We've been using the best telescopes that we had available to us to observe it for years, most notably the Hubble Space Telescope. And through a lot of observations, a map was made of Pluto's brightness, but it was very fuzzy. You have some light periods, some dark bits, but that's all we had. The Voyager spacecrafts that explored the rest of the solar system didn't go past Pluto. We had to send a dedicated spacecraft to go and have a look at Pluto because we'd never seen it before. I mean, lots of people move their personal life around their work, and mine's no different, but it is different in the sense that, you know, the spacecraft goes past Pluto once in your lifetime. And so we arranged our wedding ahead of that, and then we actually decided to wait to have children until after Pluto. When you have a mission like Pluto, you have times where you really are quite busy on the mission. You're taking new data. We flew past Jupiter, that gives you data. We're looking at the stars to make sure our instruments are still operating and they're healthy. But there are periods whereby, you know, the spacecraft is in hibernation, it's spinning, it's not taking data. If there's a problem, it knows how to call us, but other than that, it's just marching forward towards Pluto.
We lost comm with the spacecraft. Totally silent. And so you can imagine when you're in any kind of critical situation, the worst thing is lack of any information. And that's essentially what we had.
Pluto Ace, Mom, on New Horizons Pluto 1. Could you advise why we are not locking up to telemetry?
About the 4th of July, so American Independence Day in 2015, it goes into safe mode. It just stops doing anything except pointing back to the Earth and telling us there's a problem.
Mom, Pluto Ace, stand by. I'll check with the station on the status of telemetry.
So to put that into context, our encounter is 10 days at this point out, and it's a flyby. We're going to go past Pluto once. We're not going to slow down. We're not going to stop. We're not entering the system. We're flying by it. If the spacecraft wasn't back up and running by the time we flew past Pluto, our 9-year wait would have been for nothing.
Station 4-3, Pluto Ace.
Mom, on New Horizons Pluto 1. Go ahead, Pluto Ace.
We found the spacecraft. It was responding to us. It was giving us information, but it was in a state that could not accomplish the encounter with Pluto.
It takes 9 hours to talk to the spacecraft at that point. And so we were doing the tests on the ground, making sure that the sequence that we were going to upload was working.
It took us 3 days to do that. Around the clock, we slept in our offices. No one wanted to leave because we had waited all this time, and there was no way that we were going to let this opportunity slip by.
And it will transmit a message back to the Earth for about 20 minutes, in which we'll find out how it's doing. But there's a little bit of drama because this is true exploration. New Horizons is flying into the unknown.
So before we entered the Pluto system, we downloaded the highest spatial resolution observations we'd made to date. So there's only 5 of us in the whole world that had seen this image of Pluto.
Oh, my hair looks better like that.
And we're all just sitting there at that moment of like, whoa.
We've recorded data of the Pluto system, and we're outbound for Pluto.
To see that was just incredible. It was a life-changing experience.
Look what we accomplished. It's truly amazing. Humankind can go out and explore these worlds. And to see Pluto be revealed just before our eyes.
So when you see an image of a new world, especially one as diverse as Pluto, there are so many things you can take home from it. And one of the first that jumped out of me is that heart-shaped region that's in the middle of the encounter hemisphere. And in particular on the left-hand side of the heart, it's very smooth. And you don't get smooth regions on any worlds unless there's some form of active reprocessing. And so there was active geology on Pluto right now. Couldn't believe it. Still can't really. So why is it so geologically active? We still don't have all the answers. Does Pluto have a subsurface ocean? There was mountains with holes in, which points to the idea of a volcano. Maybe it's a cryovolcano, a volcano that erupts ice. And that would be better explained if there was enough heating to sort of maintain a liquid water ocean. Pluto's really cold. really, really, really cold, colder than you could possibly imagine cold. It's so cold that water there is sort of the bedrock. The ice is so hard it can form mountains, which is something that of course just couldn't occur on the Earth. And so on Pluto we see these big ice structures. So it all kind of implies that there's lots on Pluto that is quite fresh and new. And so whether you could have life that is in a sort of this contained place, subsurface, so dark, but with an energy source, it's hard to imagine from what we know of life. It's not impossible, but it's going to be a difficult thing to get to see because it's so far from the Earth. We don't want to do any harm. You certainly wouldn't want to send, a probe into this pristine world because you could kill everything that was in there just as you discover it. So it's definitely the thing of sci-fi, and it's fun to think about, but it's going to be a really difficult thing to test. Anyone that's been working at home during this lockdown will understand the frustration of limited broadband. And we have this on New Horizons because the spacecraft is so far from the Earth. Getting a signal back is so weak. It's meant that our 6 gigabytes of data that the spacecraft took during the encounter is still being downloaded. You're really trying to make sure you have everything on the ground before it gets wiped from the spacecraft, before it's gone from humanity forever. You want to make sure you have everything. True exploration isn't something that normal people get to do, right? I've got to explore worlds that have never been seen before. And I think once you've had that taste, it's just, you can't let it go. It's not quite adrenaline junkie stuff, but you want to do it again. And so it would be absolutely incredible to do it twice in a lifetime. What a privilege.
Black holes aren't what you think they are. They're not holes, they're not black, and we can actually see them. And we've even managed to take a picture of one. You are currently looking at something incredible. The first ever image of a black hole, the one at the center of the Messier 87 galaxy, 55 million light years away. Now we know there's a black hole at the center of our galaxy, the Milky Way, which is 27,000 light years from the solar system. And we know that it's super massive because in 2008, Professor Andrea Getz and her team measured how big it was and found that it was 4 million times more massive than the Sun. This measurement was such a big deal that in 2020, she won the Nobel Prize in Physics. To work this out, they studied the orbits of the stars moving at incredible speeds around the black hole and used this to weigh the black hole.
If there's a black hole at the center of our galaxy, that's going to force these objects that are really close to the black hole to move much faster than they would move if there were no black hole. So the first thing you want to see is that there are very fast-moving objects where you think the black hole is. If there's a black hole, there's a further prediction you can make about what these stars are going to do. They're going to move around the black hole on very short periods. In other words, you're going to be able to see them move on more than just straight lines. As part of their travel around the black hole, these stars are going to move around the black hole because of the gravity, just like planets move around the sun.
Contrary to their name and to common belief, not all black holes are black. In fact, the gas and dust that spirals around the black hole can be accelerated to huge speeds, which heats up due to friction, causing it to glow. In fact, feeding black holes are some of the brightest objects in the entire universe. There's a supermassive black hole in the center of every galaxy. So how do we know? When quasars were first discovered, they were thought to be hugely bright stars, and any ideas of them being black holes were dismissed as just crazy. But we now know they are feeding black holes. Now they're described as feeding because stars and gas clouds that get too close are torn apart violently by the immense gravity and then lost beyond the event horizon to become part of the black hole. They're essentially like a little snack for the black hole. There's a quasar at the center of the Cygnus A galaxy that's 1 trillion times brighter than our sun. And Dr. Andy Fabian from the University of Cambridge is studying this quasar with X-ray images. These help reveal the gas clouds that are orbiting around the black hole.
There's a lot of other things going on out there, and enormous amounts of energy being released, which we can only be aware of if we look with X-ray eyes. We could see what was going on at the center, and we could start to understand how the black hole was feeding energy out into all the surrounding gas.
The friction generated by this dense atmosphere of gases produces the hottest and most electrically charged environment in the universe.
What we know is that the hotter something gets, the brighter it gets, the more light it emits.
By feeding on all this gas, the black holes sometimes end up with just too much material around them and end up burping out a load of it, which then impacts the galaxy. This can actually expel a load of the gas that the galaxy would have used to make more stars, and essentially stopping the galaxy from growing any bigger. So black holes seem to wield a worrying amount of power. They can literally control how big a galaxy can grow.
Galaxies could, in a way, be much bigger than they currently are. Something is stopping them growing larger, and that something is the black hole at the center. Now, this is bizarre because the ratio of the size of the black hole to the size of the galaxy is the same as the ratio between a grape, or something this big, and the size of the Earth.
It sounds impossible that something that small would have so much control over something that big, but that is what's going on. It's been calculated that the mass of a black hole is on average about 0.5% of the mass of a galaxy. Essentially, the bigger the galaxy, the bigger the black hole will be. This correlation made astronomers start to wonder whether black holes might have been present or even responsible for the birth of their galaxy.
Because it really meant that there was something linking these tiny supermassive black holes in the center of galaxies with the whole galaxy itself. It meant that somehow their whole history had been intertwined, that the growth of the galaxies and the growth of the black holes was somehow related.
Now, in the early universe, we don't know if stars formed first or if black holes formed first. But if the black hole formed first, then the galaxy of stars could have then formed out of the gas that was swirling around it. What everyone really wants to know, though, is what happens when a star gets swallowed by a black hole. Well, a couple of years ago, a gas cloud called G2 came perilously close to the event horizon of the black hole at the center of our galaxy, the Milky Way.
This is the first time, really in human history, that we have not only known an event like this was going to happen, but that we are prepared with the right sort of technology to see the details unfold.
Astronomers monitoring the event were able to test the effects of the black hole on this gas cloud. It was essentially on a collision course with one of the most powerful entities in the entire universe, and it was being stretched out on its way there.
It was moving quite fast, and it's not moving in a straight line, but it's a curved line. And that's a very, very bad sign, because it tells you, well, there's something acting on it. It tells you, wow, gravity is pulling on that object.
Instead, though, it was spaghettified, and it circulated the black hole and then was essentially catapulted back out into space. Lucky escape for the gas cloud. This event confirmed that it is possible to get perilously close to a black hole and still escape. So, there's a black hole at the center of every galaxy, and they have the power to dominate everything around them. But they're not just giant hoovers sucking everything up around them. Stars, gas, dust, they're all happy to orbit them with no issues.
We're seeing the black hole at the center having a galaxy-wide effect on the surroundings.
So if they really do have a galaxy-wide stronghold, and the one at the center of the Milky Way has been there since its existence, that means that you, me, and all the stars that we can see have always, and are currently, right now, orbiting a supermassive black hole.
This is one of the few places in our solar system where we have a good chance to look for life. There's evidence for a vast subsurface ocean below the icy crust of the Moon. The amount of water that's suspected there is many times more than all oceans together we have on Earth. On the poles, you're approaching minus 200 degrees Celsius. Icicles that could be several meters high might be present. And if you're very lucky, then you might just spot a plume erupting nearby, like an ice volcano that ejects material from the subsurface to enormous altitudes. On top of that, there's a good chance that there's an energy source at the bottom of the ocean, hydrothermal activity, that can support the emergence of life. That makes Europa outstanding. Europa Clipper is the first mission that goes to the outer solar system that has the exclusive goal to investigate the habitability of a body in the outer solar system. It will launch in October 24 and will arrive at Jupiter in April 2030, so it's 5.5 years for Europa Clipper. Jupiter has like about 70 moons, so the number increases like every year by a bit. But there are 4 moons that stand out, that are the so-called Galilean moons. The innermost is Io, then Europa, then Ganymede, and then Callisto. With the telescopic observations before the arrival of the first spacecraft, you could see that some of these moons are really, really bright. They reflect way more light than a rocky surface would. And so, for example, Europa and also Enceladus, they are one of the brightest objects. And so it was suspected already at that time that the surface might be composed of shiny, reflecting water ice. I mean, after the investigations of the Galileo spacecraft in the late 90s, Europa became a prime target in planetary science all over the solar system. Because with a huge subsurface ocean, with the spectro-hydrothermal activity, that became the first place that could be habitable in our solar system besides maybe Mars. That immediately sparked proposals of missions to go back to Jupiter and specifically investigate Europa. I mean, if you are a planetary scientist, probably the most rewarding science goal is to see if a planetary body is habitable or actually inhabited. So Europa Clipper will stay in orbit around Jupiter, and in most of its revolutions, it will have a close flyby at Europa. And the flybys are arranged in a way that it's like a web in the end surrounding the moon, that you have in the end a good overview over almost the entire surface after these 50 flybys. During this close flybys, you get an idea of what is evaporating from the surface of Europa. And from that, of course, you learn about the makeup, the composition of the surface. And this is, of course, specifically true if there's plume and venting activity. That's what I really would put a smile on my face, if we could measure plume material that's connected to the subsurface ocean of Europa. The instrument called SUDA, the Surface Dust Analyzer, is the instrument I'm working on. It measures the composition of tiny grains that are surrounding Europa, mostly ice grains. And these grains are knocked off the surface by micrometeoroid impacts. With the SUDA instrument, we can sample these materials, and with that we get an idea about the surface composition. We could constrain what salts were there in the ocean, if there's an alkaline, neutral, or basic environment, if there's hydrothermal activity at the bottom of the ocean, what the organic chemistry inside the ocean has evolved to. Unfortunately, we currently only have one example of a planetary body or a moon where life exists. And so it's very difficult to speculate about the nature of life elsewhere. If we look for signs of life on an icy moon like Europa, it's probably the most straightforward to just look for simple forms of life. If there would be complex civilizations in these subsurface oceans, we probably would have known by now, right? But I know that at least for the life on Earth, the access to oxygen is important to develop complex life compared to simple monocellular life. So this is one of the big science questions that Europa Clipper wants to answer. Has the Europa Ocean access to oxygen that is created on the surface? So is material from the surface cycling back down to the ocean? If yes, then oxygen might be available in the ocean, and this opens up the possibility for more complex life. And not just a single cell, but maybe fish-like complex life. Everything between one cell or no life or fish-like life, like complex organisms that might be even intelligent or not, nobody knows. It's really up in the air. I look very much forward to the launch. It will be launched on a Falcon Heavy that was decided only a few months ago. So one of Elon Musk's rockets. And I'm really much looking forward because I never saw a rocket launch in my life. I'd like to see it. But on the other hand, it'll make me nervous. So that's always a problem. If rockets have a chance, even the safest rockets have a chance of like a 1% or 2% that there's some failure, and then everything was in vain. Because all the development has been done. Most instruments have been crafted twice, that you have a spare. So I really hope that the launch will go well. So I think it's one of the most exciting missions there is, and I'm really glad that I can participate in these endeavors.
So humans are going to Mars, and soon, lots of them. SpaceX could be going as soon as 2026, NASA and China by the 2030s, and India, Russia and the United Arab Emirates are all planning on it too. But what happens when they all get there? How can we actually survive? Well, some lucky scientists have already been there. Okay, not really. They're living in a Mars simulation right here on Earth to troubleshoot what could go catastrophically wrong when they do go to Mars. It's time to explore the unexplored. Okay, let's break this down into two key challenges we're going to need to overcome if we go to Mars: the physical and the psychological. Let's start with the physical. In many ways, Mars and Earth are quite alike. It has a similar dry landmass, volcanoes, craters, and its days are just 37 minutes longer than ours. What would you do with an extra 37 minutes? But that is where the similarities end, and it's the differences where the problems start. Gravity is just 38% of that on Earth. It means that you can jump higher, but you'll lose muscle mass. Imagine Dwayne "The Rock" Johnson training his chest every day with an 100-kilo bench press to maintain that impeccable physique. Suddenly, you land on Mars, and all that's available is a 38-kilo weight. Over time, his chest is going to get weaker and weaker. And it's a similar situation for astronauts going to Mars. Then there's the atmosphere, which is incredibly toxic. It's around 95% carbon dioxide. And to make matters worse, Mars is bombarded with radiation. And you get the idea. Mars is extremely dangerous. But luckily, there's a team of scientists who are actively trying to resolve these problems before we get there.
So when we talk about Mars simulations, what we're doing is we are trying to mimic the surface phase of a human robotic Mars mission. There's a million things that can go wrong. So when we think about Mars, we're talking about a world that is up to 380 million kilometers away from the Earth, which happens to be about 1,000 times the distance to the moon. And so it's probably 1,000 times more things that can go wrong. What we learned through our missions, it's not only the big things that are challenging, it's the small things. Think of being in the spacesuit. Despite the air condition, you start to sweat, but you cannot scratch your nose in the helmet, obviously. So little things like a little piece of foam where I can simply rub your nose into it and make sure you don't sneeze inside the helmet, which is a very bad idea, by the way, is a little thing that doesn't sound very glorious, but it's the things that make your work easier. And really making sure that you have gone through the ins and outs of those little details can be a game changer. We have been doing those Mars simulations for 13 campaigns now, since almost 20 years now. And there's literally hundreds of experiments we did, and many of them went wrong or did not turn out the way like we expected for them to do. And so we live and breathe the mantra of fail fast, fail cheap, and have a steep learning curve, because that's where you get better. We died many deaths, simulated, of course.
So gravity, atmosphere, and radiation are not actually the main concerns. These are the big things that we already know about, that we can create technology to help mitigate them. It's the small things that we don't know about yet. They're what could kill you, and there's a lot of them. So far, the answer to most of the physical challenges has been better technology and better spacesuits. But physical survival is only part of the battle. The team are also pioneering incredibly advanced psychological studies to figure out who will be the best humans to go to Mars.
We think that there's no such thing as a born astronaut. When we select analog astronauts for the Austrian Space Forum, this has been done very, very carefully. It's a multi-month process. We're evaluating, we just did a recent count from the last class, 637 individual parameters, anything from your cholesterol level to the length of your pinky finger and your ability to entertain little children and psychological factors and so on. You're much more looking for team players who are outstanding when it comes to health, but they also have technical competence, but at the same time who are also to display social warmth. They know how to tell a joke in the airlock at the right time. They know how to cook. They know how to do a magic trick. They can play the guitar. They can also settle down a broken leg or so. We are not looking into psychological clones of each other, but they need to complement each other. And so we're looking, actually from the anthropometric point of view, we're looking for the average Joe, the average Jane.
Or an average Josie?
So we have people who, in the beginning, who have a high technical competence, but then the work doesn't stop here, because you need to continuously monitoring the activities throughout the mission. That's exactly what we're doing with our simulations. For instance, we are in a previous experiment in 2018 in Oman, we had an artificial intelligence machine learning algorithm actually, who was looking into the pitch of the voices when people talk to each other. And we know when people are under stress, the average pitch shifts just slightly above the average. Or for this mission in Israel right now, we had one of the experiments, was a fantastic experiment. The astronauts would have locators, so we could produce heat maps where the astronauts would congregate throughout the mission, or also relative heat maps, how much physical spacing they have in between them. If you don't like somebody, you tend to increase the distance, for instance. And so we're looking at the methods that tell us, here's a stressful situation emerging before the people would realize it. And magically, then everything goes according to plan. And so it's about keeping them functional, by keeping them happy, by feeding them well, no food, no fight. But also making sure they don't smash each other's heads before leaving the lunar orbit.
So, with the right training, technological development, and people management, Dr. Gromer believes that we can definitely survive on Mars. But so far, we've only been focusing on a finite scientific mission. Go, survive for a bit, and then return. And that's understandable, given how many risks there are for even doing that. But this hasn't stopped people from dreaming even bigger. Elon Musk has famously said that we're going to Mars for good, to become a multi-planetary species. Some scientists have taken this and come up with some scary, speculative solutions to explain how we might survive. One of those is through mutations. The high levels of radiation on Mars could cause our bodies to change, and it's possible that some of these changes might actually help us survive. It's hard to predict how quickly this might take and the effects that it might have, but some scientists say that it could take just a few generations. Like, we could see changes in our skin tone to deal with the radiation. Could we go green? Our bone density might alter to account for the lack of gravity, and we might not even need our immune systems because we'll be living in such a sterile environment. But all of this is only relevant if we're actually going. Will we really ever be setting off to Mars for good?
Yes, we will. I can give you this in written. It's only a natural process. I think at the core of our beliefs and of our heart and our DNA, we are a migratory species. Our children and grandchildren will look up to the sky, to the moon, and see little dots of light out there on the lunar surface saying, we are out there. It's a statement to the universe. And the same will happen to Mars and the worlds beyond. It's just a matter of time.
The James Webb Space Telescope is revealing the universe like never before. Our planets, the furthest galaxies, and the strangest phenomena.
And what you can see is actually material falling into a black hole.
And that's only in the first few weeks. There's going to be a lot more discoveries to come.
The James Webb Space Telescope is a product of decades of hard work from scientists around the world.
I have been waiting my entire astronomy career for JWST. It is absolutely revolutionary compared to what was available.
It's very, very rare in science that you make a big step forward in your measurement capability in the way that JWST has done for astronomy. And it just doesn't happen very often in the history of science, and that's really exciting and significant.
One of the things that makes James Webb so special is its gigantic mirror.
So that there are various things that make the primary mirror on James Webb special and incredible. I mean, the first is the sheer size of the mirror. It's the largest one ever launched.
The Webb mirror is around 6.5 meters in size. So if you can imagine that, that's bigger than most houses that you're walking by.
It's so large it wouldn't fit in the rocket, so they had to devise a way of folding it up so that it would fit inside the top of the rocket.
It's absolutely humongous. And that makes a really big difference in terms of the sensitivity of the telescope.
Well, it's thousands of times more sensitive than Hubble. It's a step forward of factors of 1,000 or more. Factors of several thousand, in fact. I'm correcting myself.
The bigger the mirror, the more light you collect. The bigger the collecting area, the more sensitive you are and the further you can see.
The other thing that makes it absolutely incredible is the precision with which it's been made. If the mirror was stretched to be the size of the United States and you were to measure the size of the biggest bumps and dips on the mirror, you're only looking at a bump or a dip of order 1 centimetre in size. It's absolutely incredible, and that's what generates the near-perfect images from the primary mirror.
But it's not just the mirror that makes the images from James Webb so incredible. It's also the type of light that it detects. The James Webb Space Telescope detects infrared light, which is a wavelength of light that we can't see. But the unique properties of infrared make it incredible for exploration.
So with the infrared light, you can see the atmospheres of exoplanets. There's molecules in star formation regions, things like caffeine and alcohol and water ice, the signatures of life around other planets.
So just a few things then. Infrared opens up the possibilities for astronomers like Olivia and allows them to capture images that would previously be impossible in the optical range. But even within the infrared spectrum, there are multiple different wavelengths. On board Webb, there are 3 instruments that observe near infrared. This is closer to the visible spectrum. But the instrument that's garnering the world's attention is the mid-infrared instrument on board JWST, known as MIRI.
MIRI is essential for JWST. Without it, you can't see the cooler phenomena in the universe. You can't peer back as into the earlier stages of star formation as you would like.
So MIRI is an incredibly significant and important instrument. The image contains far more detail than has ever been done before.
So when we look at it in a new wavelength of light, we find things that we hadn't expected to see, and that's a really important part of how you discover things about the universe.
MIRI allows us to see further along the infrared spectrum, and this in turn allows us to see through dust clouds and further back in time than ever before. That's because as galaxies move away from us, the colour they emit shifts further into the infrared, so the longer the wavelength we can observe, the further back in time we can see. But despite the capabilities of MIRI, it very nearly didn't make it on board James Webb.
So MIRI wasn't initially part of those plans because it seemed technically very complicated, and I think people were thinking about the science in a slightly different way. And so I started making the case that really we needed to add a mid-infrared facility to the telescope.
Gillian Wright is the European Principal Investigator for MIRI and the Director of the UK Astronomy Technology Centre, and was instrumental in pitching to get MIRI on board Webb.
When I found out it was confirmed that MIRI was going to be on board, I remember being very happy and also knowing that I was going to be very busy for a large number of years.
Gillian wasn't wrong. Construction of James Webb Space Telescope started in 2004, and 17 years of work later, on Christmas Day 2021, with MIRI securely on board, the telescope finally launched.
And liftoff. Décollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
I've been looking forward for the Webb launch for many, many years. And as it got closer to Christmas Day, I was extremely nervous. I don't think my family enjoyed Christmas morning with me because I had on the TV the Webb launch playing, and I was quite nervous. I had my pillows ready in case I needed to hide.
Everything went perfectly. It was an incredible launch. It was a pleasure to watch.
So it was a very good Christmas present.
It was a lovely Christmas present, it really was.
Over the next few months, the James Webb Space Telescope travelled over 1.5 million kilometres away from Earth to its new home, gradually turning on the instruments along the way.
So then it was getting really exciting because we've been from Christmas Day all the way through until the late spring when MIRI finally gets turned on.
As the instruments are being turned on, it's both exciting and it's nerve-wracking because you know that there could be things wrong.
After decades of work, the James Webb Space Telescope was finally operational, and it wasn't long before the images started coming in.
I knew when Webb was going to take its first images, they were going to be spectacular. What had not prepared me was just how spectacular they were going to be.
The first images were just incredible, just so beautiful. It was amazing.
And then when the first images came back, I was just absolutely astounded at how good everything performed. And I've been smiling ever since. It's almost emotional.
The images are spectacular. And the only thing more spectacular than the images are the discoveries that lie within them.
So one of the things I think that's really exciting about the early images is the way they show how MIRI really adds information.
I can see details in there that I knew existed, but I never thought I'd be able to see with a scientific instrument. Some of the first Webb images released were of the Southern Ring Nebula. This is a planetary nebula, which is a star at the very end of its life. In the MIRI image, we see actually a second star. So we can see a red star and a white star. So these are actually a binary system, and that's the very first time we've seen this binary companion in the Southern Ring Nebula. This is an image of Stephan's quintet, 5 galaxies that are interacting with each other. And what you can see in this galaxy up here is actually material falling into a black hole in an active galactic nuclei. You can see the material in the galaxy is actually orbiting and falling into the galaxy itself. This is 13 times further than what we've been able to see before in the infrared.
I mean, JWST has already found the furthest galaxies we've ever seen, the highest redshift ones, the closest, and that's only in the first few weeks of operation, and that's really exciting, and I think it's an indication that there's going to be a lot more discoveries to come.
With Webb, we've designed it to answer many of the questions we already know about the universe. But as with all new telescopes, there's a realm of new discoveries.
The mysteries that will arise, I think they're really exciting.
New questions to answer.
The questions we don't know how to ask just now, and I think that's really exciting to see something that not only has nobody ever seen it before, but nobody expected to see it.
I feel very privileged to be part of this.
I'm proud to be part of JWST. It's been an amazing journey and a fantastic privilege, really, to be part of it.
I think it's just incredible. I helped make that instrument, and when I see these images, I'm just full of smiles.
Scotland's Astronomer Royal, Catherine Haymans, believes observations of the universe don't agree on its age because the mathematical models aren't quite right. She suspects our understanding of the dark universe may be an illusion.
Our best information about the universe tells us what the universe looked like right after the Big Bang. And from that data, we can come up with a model of what the universe should look like today. But what we're finding is that the universe that we observe isn't quite what we expected And we can't fully explain the universe that we're observing today. It means that we can't trust it when it tells us how old our universe is. It just doesn't add up.
Catherine thinks that although researchers have calculated how much of the dark universe is out there, they've little real idea of its impact.
We know that the stuff we're made up of, the Earth, the Moon, the Sun, everything we can see in the universe, that accounts for less than 5% of it. The rest is dark. Two components, dark matter and dark energy. Dark matter, that's the kind of the big gravitational stuff that keeps everything bound in our universe together. And then, its evil twin, dark energy, which appears to be causing the expansion of our universe to accelerate. Those are our three main ingredients, and we only understand 5% of it. So you could picture this as an epic fail for science. We don't understand 95% of our universe, but I like to think of this as a big challenge, because if we can understand that, then hopefully that will really revolutionize our understanding of everything around us.
To try and work out just how dark matter impacts the universe, Catherine investigates how it has evolved over time since the Big Bang.
So this is a map of dark matter spanning across the sky, where you can see bright spots. That's where there's lots and lots of dark matter, and as the colour gets darker, that's where there's emptier voids, where there's much less dark matter in our universe. And what we're finding is not what we were expecting. We can see clumps, we can see voids, we can see that cosmic web-like structure, but it's not exactly what we expected. It's a lot smoother than predicted for what we should see today. That's a bit of a problem, because it takes time for these dark matter structures to form.
Catherine has spent decades fine-tuning and finessing her dark matter map.
So for about the last 20 years, I've been working to map out the invisible dark matter in our universe. This is our map of the north. We've got another map of the south. And whilst this is one of the largest dark matter maps that we've ever been able to make, it's still quite a small patch of the sky. So we might have been unlucky. This might have been just a weird patch of the universe that we've looked at, but it's not exactly what we expected. And the fact that this is a lot smoother suggests that the universe is slightly younger than we first thought.
As yet, Catherine is unsure just how much younger. But her work continues.
Sent to look for conditions where life could have begun is NASA's Mars Reconnaissance Orbiter. MRO sends back more data than all other Mars missions combined.
MRO has 3 cameras on board. The first is the Marcy weather camera. It sees horizon to horizon on every orbit. So it builds up a map of the entire planet every day, so you can see a global weather map every day on Mars. The second camera is the context camera. It provides high resolution, and it's covered about 99% of the surface.
MRO has made more than 60,000 orbits. Its high-resolution cameras revealing Mars in unprecedented detail, discovering polar avalanches, shifting sand dunes, and what look like seasonal flows of sand or even liquid meltwater. Then, in 2017, MRO turns its gaze to one of the red planet's oldest features, the Eridania Basin, thought to have been an ancient sea.
Eridania Basin is a huge basin in some of the most ancient crust on Mars. It formed about 3.8 billion years ago, and it held more water than 10 times that of the Great Lakes, or 3 times that of the Caspian Sea on Earth.
And it is on the ancient seabed that MRO sees something remarkable.
MRO saw a massive 400-meter thick deposit formed from a mineral that forms in deep-sea hydrothermal environments, such as one that might have undersea vents.
Mars not only had the same ingredients for life as Earth, it also had an active environment to spark it into action.
Eridania Basin was an ancient sea 3.7 to 3.8 billion years ago, and that's about the same time when life was first emerging on Earth. This might have been a place where life could have existed, because those hydrothermal vents underneath that sea might have created a very conducive environment for life.
These initial conditions in the history of both planets look so similar that it seems reasonable to expect that this could eventually lead to life.
These actively fertile conditions are thought to survive in places like the Eridania Basin for hundreds of millions of years. But then, 3.7 billion years ago, something happens that transforms prospects for life on Mars forever.
Mars underwent a fairly substantial transformation in its climate. The climate got colder. What liquid water there was either soaked into the ground and froze or froze at the surface. A lot of it ultimately would get transported to the poles, where it forms these big, thick ice caps that we see today.
At the same time as the temperature plummets, Mars becomes more volcanically active, leading to catastrophic flooding. Water rages down from the southern highlands until, in a place known as Ekis Chasma, it plunges over cliffs 4 kilometers high. Creating the largest waterfall the solar system has ever seen. Cascading into a spectacular canyon 10 kilometers wide by 100 kilometers long. Once the floods subside, the water disappears. The only trace it ever existed etched into the planet's surface.
The strongest magnet in the universe has been discovered. It's an exotic, ultra-rare neutron star. It's called GROJ 1008-57, and it's got a magnetic field over 1 trillion times stronger than the Earth's. Stars like this are so strong that they have the power to do ridiculous things to anything that comes even remotely close. If you got within 1,000 kilometers of it, you'd simply dissolve. Your atoms would be super stretched. Their shape would warp into something completely unrecognizable. The molecular structure that makes you up, forget about it, it's gone. You'd just disappear. So nothing good can come from messing with a star like this. But how magnetic is it? Well, its field is calculated to be 1 billion Tesla. Tesla is the unit we use to measure how magnetic something is. Just to put this into context, the Earth's magnetic field is a millionth of a Tesla, but we've cooked up something far stronger in the lab. This is what 1200 Tesla did. Despite its supercharged magnetic strength, the star is actually incredibly small. It has a diameter of 20 kilometers. You might be wondering just what makes a star like this so magnetic. First, we need to find out more about how these neutron stars and their rarer subtypes come about. Neutron stars are created by the death of massive stars. Having run out of fuel, their upper layers are obliterated and the core collapses. We witness an extreme explosion, a supernova. Leftover electrons and protons come together to form neutrons, and with the right solar mass, we end up with a neutron star, a severely squashed down version of what was there before. Astronomically speaking, they're the densest thing out there.
If you dropped a marshmallow onto a neutron star, it would have the energy of an atomic bomb because the gravity is so powerful.
So they're cosmically very small, but unbelievably dense. Let's put it another way. If I had a matchbox full of neutron star material, it would weigh approximately 3 billion tons. Or let's go another way, maybe something smaller like a sugar cube. A sugar cube of neutron star stuff would weigh as much as a mountain. And I'd be very strong. But what stuff makes up neutron stars? Why are they so dense? Well, their insides are a bit of a mystery. We know that they have atmospheres made up of hydrogen and helium, and an outer and inner core made from neutrons, electrons, and atomic nuclei. But we still don't know what hyperdense matter lies at their center. So, does this density cause a star's megamagnetism? Actually, we don't know. This takes us literally to the edge of scientific thinking. Scientists believe that as a neutron star is born, the magnetic field of the previous star shrinks. Combine this with this unusual, highly dense matter, and this could cause the phenomenal magnetism it wields. So we don't really know why a neutron star is so magnetic. It's a total mystery. But the neutron star's density is just the tip of the iceberg. They are capable of far stranger things.
We observe binary systems of 2 neutron stars that are in orbit around each other, and when we observe these systems, we see them getting closer and closer together all the time. So what will happen eventually is that they're going to collide. And when they merge, the neutron stars will be completely destroyed and form a black hole.
So when 2 neutron stars fuse together, colliding violently, this can create black holes. But this can also give birth to things called magnetars. And that's what is believed to have happened with our strongest magnet. However, there's another reason it's one of the rarest stars in existence. Not only was it once a magnetar, it's now what's known as an X-ray pulsar. This pulsar is truly incredible. It exists in a binary system with another star, orbiting each other. But it's not an equal relationship. The highly magnetic pulsar feeds off its lower density companion. With energy accumulating at its magnetic poles, it gives off bursts of X-ray pulses, like a lighthouse in the deep, dark corner of the universe. Dame Jocelyn Bell Burnell discovered them in 1967 and wrote the rule book for how we monitor these phenomena.
The pulses are short and quite steep, so these things have to be small. The other thing that we very quickly established was that the pulse period was very, very constant. It wasn't getting tired, which means it's got large reserves of energy, which means it's big. So it's small and it's big. You have to be more precise in what you're saying. It's small in width. It's big in mass. So high density. That's the first pulsar, CP1919. So that's what it sounds like if you listen to the radio signal. So that's a whole star spinning at that rate. And there are some that are even faster. If you listen to the fastest one, it would sound like your kitchen blender is going at 700 revs per second.
But we still don't know so many things about stars like the strongest magnet in the universe. Crucial elements of the mystery remain unsolved. Why are these stars so magnetic? And what is hidden deep in their core? Maybe one day, the star's secrets will be revealed.
Jupiter played a crucial role in developing life on Earth. Thank you, Jupiter. We normally just see the very top layer of atmosphere. There are so many secrets of Jupiter contained below these clouds. So I'm currently analyzing data from the Juno spacecraft.
Juno, the spacecraft, has all these magical instruments to see inside of Jupiter. Jupiter is the most extreme environment NASA's ever visited. To send a spacecraft there is a little bit insane. This is one of the largest spacecraft ever made. We had to, build an armored tank to go there.
Jupiter's radiation environment is the most dangerous environment for a spacecraft to go into. It's a region we were very afraid of because no one had ever been there before.
If that doesn't fire just right, you fly right past Jupiter. That's it. You don't go into orbit, you go around the solar system again. By the time you come back to Jupiter, it's decades later.
Almost there. It's a very uncomfortable situation.
Welcome to Jupiter.
We just did the hardest thing NASA's ever done.
What we actually found blew our minds. When you first look at Jupiter, what really catches your eye is the Great Red Spot. It's this gigantic storm in the southern hemisphere of Jupiter. It's larger than the Earth. It has been around for over 200 years, and it's absolutely incredible. Then you begin to look further away, and you see these belts and zones moving in different directions on the planet, and everywhere you look, you basically see a storm. And what drives these storms? Well, likely Jupiter is collapsing very, very slowly. This is energy left from its formation, and this energy is released, and it's that energy that churns the atmosphere so violently all the time. This is in contrast to Earth, where our weather is governed by the sun. A lot of tourists go to northern Sweden and Scandinavia to see the northern lights of the Earth. If you really want to show and something that's on all the time, you go to Jupiter and see Jupiter's aurora. It's brighter than all the energy that all the power plants on Earth can produce, and is actually fueled by a volcano. So Jupiter has this moon called Io, and that's fiercely volcanic, spewing out material near Jupiter all the time, about a ton a second of material. This material gets trapped by the magnetic field as energy funnels down, impacting the planet, and that's the aurora we see.
What we find is vortices, kind of like hurricanes. They're all packed together. And we've been watching them now for a year, and they haven't all merged into one. They're packed in this pentagonal pattern. There's actually 6 of them, if you count the one in the center. And they just sort of sit there. And this is remarkable. This is really the first time that anyone has seen such a geometric pattern of cyclones on any planet or anywhere. I look at an image like that and I say, wow. The idea that nature can make such a geometrical structure is fascinating.
We've known since the Voyager missions that lightning exists in the clouds of Jupiter. What Juno's found is there's a second form of lightning at Jupiter.
This is the signal from the microwave radiometer, and it's measuring the heat of the planet, and every now and then we get a spike. Bam! It became very clear very soon that this was radio signals from the lightning in Jupiter's atmosphere. Maybe 1,000 times brighter than the lightning on Earth.
The presence of lightning at Jupiter hints at vast amount of water, and Juno's actually confirmed that in the lower part of the atmosphere, 1 out of 400 molecules is a water molecule. That's a lot of water. Does that mean that there's life in Jupiter's atmosphere? Well, ultimately, we don't know. We have this notion of what life is based on our experience here on Earth. Can we translate that to Jupiter? Can there be life forms floating about in the atmosphere? We don't really know. Jupiter is so massive, about 300 times more heavy than the Earth. And with all this gravitational power comes huge responsibilities. Jupiter originally flung water into the inner solar system, creating the conditions for life at Earth. So thank you, Jupiter. It also likely altered the orbit of an asteroid that killed the dinosaurs 65 million years ago. Jupiter's presence, gravitational presence, is absolutely everywhere.
This is the outline of Jupiter, and basically what we're seeing there are just the cloud tops. But what we want to know is what's inside Jupiter.
Before Juno, we believed that Jupiter had a really small core onto which gas just stuck by gravitational forces. And what Juno has found is actually that Jupiter has got a really big core.
There's something denser. It's probably like 5–10 Earth masses. It's mostly made of rocks at very high pressures and temperatures. So that shows that Jupiter started its life as a rocky, icy world, and that it captured the gas that was around, the hydrogen and helium. And that formed a giant planet that's Jupiter now.
I first became interested in Jupiter when I was at college in Sweden. There was a telescope on the roof, and one night we got to see Jupiter with our own eyes, and it was absolutely extraordinary. A whole different world that I can see right there in the night sky. What would he think about me today? I think he'd be proud, ecstatic.
The Milky Way could fit into the universe as we know it 10 million times. So it's big, really big. And we know that it's expanding at an exponential rate, which means that in about 1 billion years' time, the universe will be about 10% bigger. So do we know how big the universe is right now? And could we ever actually map out the size of the universe? So let's start with the bits of the universe that we can actually see. Light has a speed limit, so there's only so much of the universe that we can actually see, and we call it the observable universe. We think there are around about 170 billion galaxies in the entire observable universe. What we really need to work out how big the universe is a 3D map of it. That's what the Sloan Digital Sky Survey is trying to do. With 3 coordinates, you can make a 3D image of where to find all of the galaxies in the universe. By placing the plate with the galaxy coordinates over the telescope, they could isolate each galaxy individually and work out a 3rd coordinate for each one. That third coordinate was redshift. And with redshift, the team could get the distance to each galaxy from the Milky Way. Dr. Slagle called it a 3D movie on a colossal scale. His team essentially brought the stuff of science fiction to life. Using this new map, cosmologists were able to see how galaxies were arranged in space.
Maybe you've seen things like this in the opening of Star Trek or Star Wars or whatever, and that all looks great, but it's not real. This movie, it is the real universe.
Just like our galaxy, the universe is held together by gravity, but there weren't enough galaxies to generate enough gravity to actually hold the universe together. Most of the stuff in the universe was missing. So this map led astronomers to some more evidence for something they'd been theorizing for quite a while now.
It's simply not enough stuff to arrange things into the patterns that we see, have galaxies spinning in the way that they do. There's something else there. There's something beyond the galaxies that we see, the visible matter.
It's called dark matter. It's invisible, and we haven't found a way of detecting it in a lab yet. I know it can seem like us astronomers just start making up wild theories when we don't understand maybe what's going on, but we do know dark matter is there, in the same way that we know the wind is there because we see the trees move. We have so much evidence for it, including the fact that the gravity it generates is literally holding the cosmos together.
What we're finding out there in the universe is really weird. It's equivalent to the idea that only 1 out of 6 cities in America actually has any people living in it.
There is 6 times more dark matter than there is in all of the stars and the dust in 170 billion galaxies in the entire observable universe. So does that mean that the universe is 6 times bigger? Well, no, not quite, but the universe is certainly 6 times heavier than we thought. And it's complicated by the fact that the universe isn't just full of invisible stuff that we can't see, but the stuff that we can see is also moving away from us. The universe is getting bigger, literally, as we sit here watching it.
It's an observational fact that if you look at the galaxies around us and the most distant galaxies that we can see, they all appear to be moving away from us. If you were standing in California, you would see New York moving away from you. But from the perspective of New York, you would see Boston move away.
By observing the brightness of supernova, Professor Saul Perlmutter and his team proved that the universe is not only expanding, but that its expansion is speeding up at an alarming rate.
At the end, we concluded that actually the universe really isn't slowing down. It's actually speeding up in its expansion. And that was a big shock.
Professor Perlmutter's discovery was so important to the scientific community that in 2012 he was awarded the Nobel Prize in Physics. So after you establish something like that, the question on everybody's minds is why?
Well, we don't know, but we did work out what to call it. We have a name for it. We call it dark energy.
And we figured out that the universe is about 68% dark energy.
The really crucial thing about how this dark energy behaves is that it doesn't dilute. When the universe doubles in size, you got twice as much dark energy. Make it 4 times as big, you've just got 4 times as much dark energy.
So how do you measure something that's big, that's getting bigger, that's full of stuff that we can't see? Well, unsurprisingly, you can't, or at least we can't yet. But what we have done is map out the stuff that we can see. And as usual, the universe has done things that we never expected it to do. And that map revealed that the universe is flat. Cosmologists plotted 3 points of a very big triangle that went from Earth to 2 points in space-time as far back as we could go.
If the universe were positively curved, if the angles inside the triangle added up to greater than 180 degrees, then it would be finite in size. If the spatial geometry is flat, if the angles inside the triangle add up to 180, then it could go on forever.
The answer was mind-blowing. Space itself is flat. Now, we're not talking about the shape of space here. We don't mean space is flat like a piece of paper. We're talking about how light behaves in space. For it to be flat, it means that light would travel on in an infinite direction and never be disturbed. If space wasn't flat, that light could loop back on itself. It'd almost be like if you could stare out for long enough and detect light faint enough, then you would be able to see the back of your own head.
That means that the simplest picture of the universe is a universe that's infinite. We really could live in a universe where there's galaxy after galaxy after galaxy in every direction, up, down, sideways, and it never stops.
This provided the perfect picture of what the universe looks like. An infinite universe filled with galaxies in all directions that is still getting bigger. Absolutely mind-boggling.
What powers weather is very different depending on where you find yourself in the solar system.
The Earth's atmosphere and the weather on Earth is driven largely by one thing, and that's the sun. And the sun pours its energy down through the atmosphere, and it hits the surface, and the surface of the Earth then warms up.
With Earth, you've got all the energy coming in from the sun, heating up the surface, creating thermals that then drive the atmospheric flows that we see. Somewhere like Saturn doesn't have a surface to be heated up. So when you compare the weather systems on these giant planets to those that we have on Earth, you have to sort of tear up the rule book a little bit.
The sun is the great controller of Earth's atmosphere. But in the outer reaches of the solar system where Saturn lives, sunlight is 100 times weaker. It means some other heat source must be driving Saturn's incredible weather. As Cassini studied the cloud tops of Saturn, it was able to infer a huge amount about the truly strange world that must lie beneath, and the energy source that helps power this planet.
We had a whole variety of scientific goals at Saturn, and one of the main ones was to understand the meteorology of the Saturn atmosphere and what energizes the winds that we see on it and so on. And we have affirmed now the belief that atmospheric systems on Saturn are actually powered by energy from below, from an internal heat source on Saturn. They're not powered by sunlight like we have on the Earth.
Looking deep inside the planet reveals a heat source shaped by extreme pressure. Within huge clouds of water, Cassini records lightning 10,000 times more powerful than any on Earth. This lightning transforms methane gas into enormous clouds of soot. At 8,000 kilometers deep, the pressure of the atmosphere is 80 times greater than that at the bottom of our deepest oceans. Enough to transform this graphite rain into diamonds. But even these diamonds are likely destroyed by the pressures of Saturn, eventually dissolving. "30,000 kilometers down, and Saturn's heat source is revealed. Here, pressures are so intense that the atmosphere behaves like a liquid metal, able to conduct electricity. In this state, molten helium falls like rain. And as it merges with the surrounding material, kinetic energy is released as incredible amounts of heat. And it's this extraordinary heat source that helps drive Saturn's weather. Within just a few 100 million years of its birth, Saturn has witnessed great drama. Now it will remain largely unchanged for billions of years.
It has the biggest volcanic plumes that we know of, with exotic sulfurous compositions, the highest temperature lavas that we've detected. It's as hot as 1800 degrees Kelvin. So Io wins lots of awards for being extreme. Some of us love Io just for its own sake. But it's also a laboratory for understanding other planets, especially the terrestrial planets very early in their history. When they were hotter, they had more heat. This was a time when life first formed, when plate tectonics was getting going. We'd in many ways, studying very early Earth is like studying another planet. Understanding Io might teach us something fundamental. I'd like to understand that type of volcanic eruption without having one happen on Earth today. That would be unfortunate for all of us living here. Io, that's happening today. Very high fusion rate volcanism, more active than the most active volcanoes we usually have on Earth. And it changes our whole view of how planets work. For terrestrial planets like the Earth and Moon, our thinking is that it's kind of like the lifetime of a human being. When you're young, you're energetic and active, and then you get more quiescent and more quiescent, then you die. Boring. Well, these outer planet satellites are much more like the Hindu life cycle, where you can be reborn and go through all sorts of cycles of activity. So very different concept of how planets work. We have no shortage of unanswered questions and mysteries throughout the solar system and beyond. Right. Io is a little bit larger than Earth's moon. It's one of 4 large moons of Jupiter. It's the innermost of the 4 large moons. And 3 of these moons are in a resonance. So every time Ganymede orbits Jupiter once, Europa orbits twice, and Io orbits 4 times. This means that the distance to massive Jupiter is varying, and the whole moon changes its shape, where the surface of the moon rises and sinks as much as 100 meters. In case of Io, every 42 hours. That changing of shape, it's like bending a piece of metal back and forth. It heats it up. So we've proposed the Io Volcano Observer in the Discovery program. That's NASA's low-cost category of planetary mission. But this mission would make 10 close flybys of Io while orbiting Jupiter. It has a suite of instruments, and the tour is designed so that we fly by Io at just the right times and places. In order to measure the tidal gravity signature, we have to have pairs of identical flybys, one when Io is closest to Jupiter and one that's otherwise identical but when Io is furthest from Jupiter. So it sees the same signal except that this difference in range to Jupiter, which changes the shape of Io. That'll tell us really what's going on inside Io. Does it really have a magma ocean? And even if it has a magma ocean, what type of magma ocean? That's really, I think, the most fundamental thing. And we need to get a spacecraft that makes close flybys of Io at a minimum. Landing on Io and orbiting Io would be even better. You have to understand, though, Io is deep within the intense radiation of Jupiter. So Jupiter has a very powerful magnetosphere. So it's a very high radiation environment. It's very tough on electronics. So, we're not going to explore Io the way we have Mars with these long-lived rovers on the surface unless we have a revolution in electronics and how to withstand the radiation. So fast flybys is the way around that for now. Get in there close, get a bunch of data, and get out of that radiation as fast as you can. There are volcanic plumes up to several hundred kilometers high, very spectacular, and some of that material may be directly escape Io, but also that high radiation environment and those energetic particles interact and strip off material. If we're so close that we're flying through a lava fountain, that would obviously be bad for a spacecraft. We hope to fly through the upper parts of plumes where it's mostly gas and very small particles that are not hazardous. Of course, if you make a math error and impact Io, that would not be good unless it was intentional to dispose of the spacecraft at the end of the mission. And that is how we would plan to end it all after the mission is over. It would mean a great deal to me to see this mission go forward. Now, I'm not going to be the one leading the mission at Io. It has to be the next generation. You have to think in terms of multi-generations when you're dealing with the outer solar system, and especially when you have to spend a decade just to get the mission approved. So for me, though, that's all fine. I get it started, and then I enjoy life and enjoy watching others carry on. And I have no doubt that Io will surprise us. It's a very surprising place, and it's surprised every mission that's ever looked at it. The conventional thinking is that there's no way there's life on Io. It's too hot. Well, it's only hot over 1% of the surface. There are certainly places with better temperatures. It's also thought that there's no water. Well, we haven't detected water. But we didn't think there was water on the moon either for a long time until we got better measurements. So we might be surprised about that. And also, what kind of life are we talking about? The only thing we know how to talk about is life as we know it, which is carbon and water-based life. So if it's some other kind of life, then who knows? All bets are off. So it's the surprises that will be the most fun and the most significant.
Wormhole scientists are absolutely buzzing. So what's going on? Sci-fi writers have always loved wormholes. They're a convenient way to whiz a character through space at impossible speeds. But for years, scientists didn't really take much interest in them. Luckily, there has been a recent boom in wormhole research. So what's happening? Could we one day travel through a wormhole? And what would happen if we did? Let's explore the unexplored. Let's start with what a wormhole actually is. You've probably got an image like this in your mind, a tunnel or a bridge. And that's exactly what it is. A bridge between two parts of the universe. One way of thinking about a wormhole is almost like two black holes back to back. The black holes warp the fabric of space-time so much that it completely bends back in on itself, and the openings can allow you to pass straight through from one point to another. To understand how these sci-fi-like wormholes might work, we first need to understand the traditional idea of a wormhole, one that's equally as interesting, but perhaps a little less useful for space travel. A non-traversable wormhole. To help explain that is theoretical physicist Juan Maldacena, one of the pioneering experts in wormholes, who's actively researching some very exciting, albeit mind-boggling, science.
So a non-traversable wormhole is a bit like this picture of the tunnel. And so with the exception that it's a tunnel that is present at one moment in time, and then at later times it stretches and becomes thinner. And eventually it collapses completely and it stretches almost infinitely. And so if you try to traverse this tunnel, you would go into the tunnel and the tunnel closes before you can exit on the other side. So that's why it's called non-traversable.
And this closing of the tunnel is similar to, well, it's the same actually as the singularity you have in the interior of black holes. And so if you try to go through this tunnel, you would die. So it's not recommendable it's not recommended.
Right, so this doesn't seem like the most practical wormhole in the world. There would have been a lot of very short sci-fi films if the leading character just hopped into one and immediately died. On the other hand, you could binge watch all of Doctor Who in about 5 minutes. So how could we make one that we could actually travel through? The previous thinking was that wormholes would immediately collapse because they're so inherently unstable. What was missing was some sort of matter that would prop the wormhole open long enough to travel through. And this is where it gets interesting.
To have a wormhole that can be held open and be traversable, just as a theoretical question of whether it is possible with the matter we know, it is possible, but only when they are very small. Now, you can also ask the question of whether could we discover some other type of matter so that we could have a very big wormhole that we as a person could go through. And the answer to that is yes. So we could have some new form of matter that hasn't been discovered. It's very unlikely that this form of matter should exist. That should put that from the very beginning. But it is theoretically possible to have that kind of matter. And they would have to be, their mouths have to be very big so that they wouldn't kill the traveler. Because if a person goes through a region where the curvature of space is relatively large, you would be full, your head is full from your toes, and you would die. So you have to make sure that the curvature of space-time is weak enough. And for that, you need that the mouth of the wormhole should be as big as the size of the Earth. So very big, so much bigger than ourselves.
Keeping up? Right, so there's the traditional wormholes, the non-traversable ones that as soon as you enter, they collapse. Bad idea. So what do you do when something collapses? You prop it open with something. Good idea. And what do you prop it open with? Wood, scaffold, a force field? No. A weird type of matter that opposes the force of gravity that stops the wormhole from collapsing. We don't know if it exists, but it theoretically could. It doesn't defy the laws of physics. Simple. Well, there's more.
And then with this type of matter, you could have a wormhole, but it would take a long time to go through it as seen from the outside. So you could have one here and one on the other side of the galaxy, let's say, or some far away. And then you could go through the wormhole. It would take you, let's say, 20,000 years. And that is the time for someone that remains outside. But for the traveler, it could take a very short time, like a second. You would just go through it and you start traveling very, very fast. And because you travel very fast, your clock runs much more slowly. And for you, it looks like it was just 1 second.
So, in theory, we need a new type of matter that we don't know exists yet to have antimatter properties that allow it to prop open a wormhole the size of the Earth. And if we make it through without any particles tearing through us and avoid having our bodies stretched and our heads pulled off, if all of that happens and we make it to the other end, everyone you know would be dead. Great. Look, needless to say, this is all theoretical, but it is based in real physics and it's incredibly exciting. There's a big buzz around wormhole science at the moment, which is usually some sort of side area of research. And this is down to some new breakthrough discoveries. Scientists have finally proven that entering a black hole is not necessarily a one-way trip. While this probably won't help with the issue of traveling through a wormhole, it does stop the laws of quantum mechanics from breaking, which is a big relief to a lot of people.
There's a development that has happened in the last couple of years where people have realized that something similar to wormholes are responsible for getting the information out of black holes. So there was this famous information problem for black holes that you can send information to a black hole and the black hole would emit Hawking radiation that apparently has no information. But it seems that wormholes managed to get this information out of the black hole. So yeah, that's, I think, the most exciting development of the last few years.
So previously, people thought that anything entering a black hole couldn't leave it. This was known as the black hole information paradox. Even though black holes emit radiation, Stephen Hawking suggested that this radiation didn't contain any of the information pertaining to what went into the black hole.
I discovered that black holes are not that black after all. They give off what has been called Hawking radiation. Because of this emission, black holes will lose mass and eventually evaporate completely. The Hawking radiation seemed to be random and featureless, so it appeared that all the information about what fell in the black hole was lost.
However, new studies suggest otherwise, that in fact you can decode information coming out of a black hole and it's not lost forever. So, wormholes could exist, and they're far more weird and complex than movies would allow you to believe. Okay, they're far less practical, but when has practical ever been fun? So, if you're ever hurtling through outer space, headed towards the barrel of a wormhole, and you previously would have thought about going in, you'll be pretty glad you've seen this video.
Tucked away on the outskirts of Washington, D.C., an anonymous building is home to a small team of solar weather watchers.
We can be hit by the next solar storm anytime soon, because they happen fairly frequently.
Yari Collado Vega is a director at NASA's Space Weather Analysis Office.
Good morning, everybody. Is there any activity today?
Everything looks quiet so far today.
Her team's job is to keep satellites and astronauts safe from the ever-present threat of space weather.
Space weather is the activity in space that is mostly dominated by the sun. We have the solar wind, which is the expansion of the solar corona, and is always there.
The solar wind is a stream of electrically charged particles that flood from the sun and continually bathe the Earth. We see its effect through the glowing gas it creates at the top of our atmosphere, the aurora. This solar wind is a constant presence, but sometimes activity on the sun's surface increases dramatically.
The sun can also have big, strong solar storms that come in different types. We have the solar flare, which are big, bright eruptions of radiation. And we also have coronal mass ejection, which are big explosions of particles that travel through space.
Coronal mass ejections, or CMEs, are enormous bubbles of electrically charged particles that explode from the sun's surface at millions of miles per hour. And not only can they destroy infrastructure here on Earth, they can fry the electronic circuits of satellites in a flash, and are even a potential threat to human life.
Coronal mass ejections can actually cause damages to the instrumentation of the satellites that we have in space, which is the satellites that we use for technology every day on Earth. You know, communication problems, GPS signal loss, and in the scenario of astronauts, it could cause a radiation hazardous environment for them. We send astronauts to the moon, and then in the future years to Mars, they're not going to be protected. We have to make sure that we send those astronauts to space safely. So we need to make sure that we can predict those events.
Yari and her team keep a constant eye out for solar superstorms. And when they spot them, assess their severity.
Our job is to do the predictions when you have a coronal mass ejection. And when we do that, we actually can see how the CME explodes and how it actually travels through space. And then we inject the CME into a simulation, which is what we have here. You can see here the sun, the Earth, and you can see the planets and the missions across the solar system. And this is like looking at the sun from the top. And you can see here a very small CME being ejected. And we use the images here so we can actually predict where they're going and when they're going to hit.
Neptune. An ice giant, 17 times the mass of Earth. Over 1.5 billion kilometers farther from the Sun than Uranus, Neptune is almost chemically identical. Yet bizarrely, it couldn't be more different.
Neptune, in a way, was almost a relief because it wasn't featureless. You know, it's like, oh, good, a planet with clouds and features again.
Neptune was a great excitement. It's got swirling clouds, really strong winds. At 1,500 miles an hour, incredibly fast, the fastest winds that we've got in the solar system.
One of the things that Voyager discovered was an immense dark vortex within the atmosphere. A huge, swirling dark spot.
We say it's a giant storm, but just those words don't fully contain. We're talking about a storm the size of the planet Earth or larger.
And the surprises keep coming. Even though it's much farther out, Voyager discovers Neptune is warmer than Uranus. And the source of the heat is another oddity of this strange planet.
In fact, when we look at this dynamic activity in these extraordinarily cold regions, we really are at a loss to understand just what's going on here.
One theory is that the buildup of pressure beneath the thick layers of cloud turns the carbon and the methane into a rain made of diamonds. They then melt as they fall into the interior of the planet, producing the extra heat. As the heat makes its way out into the frozen cold of space, it churns the entire atmosphere, whipping up winds around the globe.
There are no mountain ranges, no valleys, no continental boundaries to get in the way of the perfect fluid dynamical flows. What that means is that when you start a weather pattern going, when you start a vortex spinning or you start a plume rising, there's very little to get in the way of it.
So those winds that develop and go around, they just keep going around and around. There's nothing to slow them down, no friction with the surface.
And the extreme cold here makes the atmosphere less viscous. Creating supersonic winds that outpace anything seen on Jupiter or Saturn. Voyager 2 has almost completed its grand tour. But before heading out into interstellar space, one last world awaits. Around 100 million years ago, an asteroid 10 kilometers across is ejected from the asteroid belt. Dislodged from its orbit by Jupiter, it is now on a collision course with Earth. When it strikes, the impact generates a fireball so hot, anything within a 1,000-kilometer radius dies instantly. The impact throws some 300 billion tons of sulfur up into the atmosphere. And during the nuclear winter that follows, 75% of species, plant and animal, are wiped from the face of the Earth, including the largest creatures ever to walk on its surface. By driving the dinosaurs to extinction, Jupiter cleared the way for us to inherit the Earth. And although it still occasionally flings asteroids our way, Jupiter also protects us. For objects heading toward Earth from the far reaches of the solar system, the giant planet's immense gravity acts as a shield. Around 100 years ago, a lump of rock and ice 4 kilometers across is hurtling towards the inner solar system. But Jupiter stands in its way.
5, 4, 3, 2, 1. We have ignition and liftoff of Atlantis and the Galileo spacecraft bound for Jupiter.
70 years later, a mission launches that will witness just how effective a shield Jupiter can be. On board the Space Shuttle Atlantis, the Galileo orbiter. Three years after Galileo launches, comet Shoemaker-Levy 9 has been captured by Jupiter's gravity. And now, locked in the giant planet's deadly embrace, tidal forces begin to tear the comet apart. Its journey into the inner solar system cut short. What happens next presents the Galileo scientists with a unique opportunity.
And so everyone was observing it, and they realized two things. One is that it had just passed very close to Jupiter and probably had gotten pulled apart by Jupiter's tides. And the other was that it was going to crash into Jupiter 2 years later.
The discovery that a comet was about to hit Jupiter was a huge surprise and very exciting.
After crossing the inner solar system, Galileo is approaching the spot where it will witness the comet's final moments.
We knew Galileo would be able to see the flashes directly. We knew that the impacts were going to occur on the night side and that Galileo was going to be able to see them.
On July 16th, Galileo sees the first fragments of the comet enter Jupiter's southern hemisphere.
At 60 kilometers per second, the fragments really heated the atmosphere, red hot, almost to the temperatures of the sun.
And the pieces hit the planet one after the other.
Pieces of comet Shoemaker-Levy 9 strike Jupiter over the course of 6 days.
They looked like big flashes on Jupiter. The pictures of the impact were fantastic.
These tiny points of light, captured from 240 million kilometers away, are the only time a comet strike has ever been witnessed. The most destructive impact releases energy equivalent to 6 million megatons of TNT, leaving behind a giant dark cloud 12,000 kilometers across. By capturing objects in its orbit and incinerating them on impact, Jupiter protects us.
70% of our universe is made up of something so weird and so strange, it continues to baffle the world's brightest minds.
We are absolutely still lacking great ideas.
It is crying out for some new breakthrough, new thinking.
Perhaps the greatest remaining mystery in our universe. What is dark energy?
Dark energy is basically our name for that thing that we don't understand.
It's not the color dark, it's just an expression of our ignorance as to what is this stuff.
Engineers could come up with a new theory. Yeah, it is quite possible. I'm kind of hoping it's me.
So this is clearly a huge deal in physics and raises many, many questions. The obvious one to start with is, why do we think dark energy exists? Now, ever since the Big Bang, our universe has been expanding, with space itself stretching, moving galaxies further apart. Now, physicists used to think that the energy that was made in the Big Bang to power that expansion would eventually start to run out and the expansion would start to slow down. Then, a Nobel Prize-winning discovery turned all of that on its head. Saul Perlmutter and his team measured the way the universe was expanding by comparing the brightness of supernova. This is when a star runs out of fuel at the end of its life.
They brighten as a firework and fade away, and they reach the same brightness. And you can then use that as an indicator of how far away it is by just looking to see how bright it appears to you. Just like when you watch a car recede into the distance, you can tell how far away it is by how faint the taillights look. If you can use the brightness of the supernova to tell you how far away it is, that's really telling you how long ago the explosion occurred, because you know how long it takes for light to travel that great distance.
And what they discovered definitely shook the physics world.
Suddenly, he was saying that we lived in a universe that was accelerating. I remember it just being incredible. I mean, all the astronomers walking around, scratching their heads, saying, this can't be right, surely it can't be right.
Now, exciting as this finding was, like many things in science, it raised a lot more questions than answers.
Once you know that the universe is actually speeding up, then you're faced with the question of, well, what could make it speed up?
This mysterious thing that was causing this newly spotted phenomena that no one could explain was immediately called dark energy. Now, it's great to have a name for this, but it doesn't exactly explain what is driving this accelerated expansion. So what is this energy? Now, just like with dark matter, which makes up 25% of the universe and is also currently unexplained, this weird type of energy seems to defy our laws of physics and has properties that our current models just cannot explain.
So you can think of it as you get more space, you actually get more dark energy, which is like getting something for nothing, which is clearly ridiculous. The way we think about it is that it's either some new stuff in the universe, some particle, or even just a new field that you put into the universe to explain the properties of the universe.
So what is it that's changing the way our universe evolves? Well, scientists differ in their thoughts of what it could be, from a liquid or a brand new particle like dark matter, or even an unknown force. Now, scientists at Berkeley in California are looking for something that they call chameleon particles. This is a whole new type of particle that's thought to create a force, which when it interacts with other particles, changes those particles' mass. By putting atoms in a vacuum, they're hoping to expose these chameleons.
The experiment works
by first collecting a cloud of cesium atoms on top of the spheres. And the atoms are free to fall, subject only to the Earth's gravity and the potential chameleon force. We will either discover the particle or rule it out once and for all.
So far, they haven't found any evidence for these chameleon particles and their elusive force, but it is an idea that continues to be explored. So whatever this energy is, we now know that it makes up a whopping 70% of our universe. So how can we figure out what it is? Now, the obvious place to start is by looking at how the universe formed and has evolved with incredibly powerful telescopes.
One of the things that I do is try to simulate the entire universe and tie what we think about the physics of the evolving universe to what we actually see with surveys like DESI.
DESI, the Dark Energy Spectroscopic Instrument, is one of these incredibly powerful telescopes observing the distant universe. Now, the further away galaxies are, the younger they appear to us. That's because light takes time to travel to us. It can take even 1 billion years to reach us here on Earth. Thanks to this, we can look at the average distance between galaxies at different cosmic times and look how it's changed due to the expansion of the universe, and therefore figure out what is the role of dark energy. But what we need to do that is more detail, and we get more detail from more data. Now, there's a lot of projects and telescopes that are mapping the universe in this way, but one that we're all very excited for is the launch of the space telescope Euclid in 2022. It's the most powerful telescope ever created, even dwarfing the iconic Hubble Space Telescope. So it could be just what we need to solve this problem.
These are going to be the biggest images that come down from in orbit. You have an image effectively of 625 megapixels. So that's roughly 300 HD television screens full of data, and that comes down every 10 minutes. This image takes roughly the same amount of data that Hubble has taken and will take in its entire lifetime in 1 day.
The hope with Euclid is that it will be able to give us the detail that we so desperately need to be able to solve this problem.
We have lots of theories and hundreds of models that could still fit our data. When Euclid comes, lots of these can be thrown away, and it could narrow down the possibilities of what this dark energy is.
Euclid will give us a coherent data set that we can test all these theories against.
So dark energy remains the biggest mystery in physics, but with all these great scientific minds across the world and all the projects focused so desperately on figuring out what this is, it might not be long before we finally find this huge missing piece of the puzzle.
We need teams like Euclid. That's the only way you can get the data that you need. But to understand that data, to give it some interpretation, to give it an idea, could come from one person. That could be the next Einstein.
Is the signal real? If the signal is real, we still have to be able to explain what or who is making it. I've dedicated my entire career to finding life beyond our Earth, and lately I've been trying to find it on Venus, the planet next door.
Oh wow, life on Venus. That just blew me away.
Venus, it is an absolute hell. The temperatures on the surface average about 470 Celsius, which is hot enough to melt lead. Air pressure on the surface is what it would feel like to be about 1 mile under the ocean. Because the clouds of sulfuric acid are so dense with haze, Venus became a desolate hellscape. The Veneer missions were an extraordinary program. Several of the Veneers didn't even attempt to land. One of them lasted 127 minutes and provided a lot of data. Some tried to take pictures, but the lens caps wouldn't come out, and by the time we got to 7, 8, 9, 10, 11, 12 Veneer missions, we had managed to get to the surface of Venus, take measurements and be sure of its intense temperatures and pressures, and also the hurricane level winds that were passing in the atmosphere.
When they eventually got the correct sort of radar going through the clouds and seeing what was going on, and then it got really exciting. Then we thought, this is a planet with a lot of volcanoes on it, and even more fascinating, volcanoes unlike any we see on the Earth.
These volcanoes had been partly responsible for spewing out gases that led to Venus becoming the fiery hell it is now. But recent data shows there may still be life left in them yet.
They found that Venus had hotspots within it, something active on Venus. That really is quite exciting to actually see these.
We do know life is very resourceful, and there is one place on Venus that could host life. If there is alien life in the clouds of Venus or anywhere else beyond the Earth, we have very little hope of ever actually seeing them. But we can look for the gases that life produces, and that is what I've dedicated my entire career to do. My specialty is looking for a gas called phosphine. It was just here, you know? I was actually trying to find my phosphine molecule. Okay, well, we lost phosphine, which actually is very fitting. On Earth, phosphine, it's produced by life that doesn't care for oxygen. So I thought maybe we could find phosphine on other planets that are oxygen poor, and there it would be a very robust sign of life. An astronomer from Cardiff named Jane Greaves reached out to me saying,
"Oh wow, perhaps there really are these floating microbes."
They needed some help interpreting a potential signal from Venus obtained with the ALMA telescope that seemed to indicate there was a sign of phosphine in the clouds of Venus.
When you go really high up, so about 50 kilometers up, the pressure in the clouds is like it is at the surface of the Earth, and the temperature's actually like 20 or 30 centigrade, so it's really quite habitable.
Jane and the rest of our team used 2 telescopes, many months apart and in completely different parts of the world, to look at the atmosphere of Venus. And these 2 independent observations agreed with one another.
So that was January 2019 when I was reasonably sure, and that's June of 2019. I'm like, here it is again.
I at first did not believe it, but there was a small part of me that thought my whole career had been for something.
It's really obvious there's something there, so that kind of blew me away.
Maybe all the work I had done saying that phosphine was a sign of life was just going to pay out right now.
Astronomers have announced they found what could be evidence of life elsewhere, and not on Mars, but on the much more inhospitable Venus.
There's something seriously weird going on there. Perhaps this is life. And that just blew me away. It was so exciting.
So you can see that really they look very like each other. So it was a robust result. 2 telescopes, nothing to do with each other, saw the same thing.
My second instinct that kicked in quite quickly was, is the signal real? If it is it for sure phosphine, or could there be another molecule mimicking it? And if it is real and it is phosphine, was I right in saying that only life could produce it?
Well, there are 2 ways that it could possibly be life. One is there's just a completely different biochemistry there. It's radically different from anything we imagine on Earth. The other way, that in principle, a more water-loving life, a bit more like the biochemistry you see on Earth, could hide itself away inside a protective shell of some sort, inside the sulfuric acid droplets.
There's questions on whether even the signal is real. If the signal is real, there are questions on whether it is phosphine or potentially other molecules that can mimic the same signal, like sulfur dioxide. If the signal is real and it is phosphine, we still have to be able to explain what or who is making it. And only then could we consider that we have found life. We're all just trying to figure out the truth. And I would love for there to be phosphine, but primarily I would love to know what's happening in the clouds of Venus, phosphine or no phosphine. And the rest of the community is doing the same thing.
Really hoping somebody will come in and say we could start to plan for a space mission. And fly through the atmosphere would be super exciting. And given they managed to get a lander to the surface and signals out in 1985, that's got to be possible, right?
We are only just now beginning to be able to even interpret the signals from places that could host life. It's a really exciting time to be discovering potentially the first one of those signs in the planet next door. But there will be many, many more to come.
The deep ocean is an alien world. But incredibly, Earth is not the only place in our solar system that has oceans. Oceans that could support life.
Wherever we find water, we find life.
I want to get data back from a probe and be able to say, it's life, Jim, but not as we know it.
NASA is planning to launch a mission to explore the methane oceans on Titan, Saturn's largest moon. Yep, you heard that right. Oceans of methane, essentially oceans of liquid farts. They're building a drone to fly over the surface and look for signs of life. Can you imagine the freedom of exploring a planet in that way rather than being stuck on 4 wheels on the surface? But most excitingly, they're also planning to build a submarine to dive under the surface of these methane oceans in search of life.
That first picture, are you kidding? That first picture from a submarine, from anybody's submarine on the surface of a sea on another planet in our solar system changes the world. I mean, that's something that none of us have ever seen before. That is true discovery. That is why we do any of this. And that would be awesome. That first picture alone would make this entire mission worth it.
It was back in 2005 that the Cassini-Huygens probe revealed this surface that really did look quite Earth-like. In fact, it revealed these lakes that had an uncanny resemblance to the Great Lakes of North America. But these aren't lakes of water, they're lakes of methane, and at minus 180 degrees Celsius, they're far too cold for any life form with an Earth-like chemistry. So we're looking for life, but not life as we know it.
What I'm really interested in finding is what I call a second genesis of life. Organisms that are clearly not related to any life on Earth.
But is it even possible to have life that can survive on methane rather than water? Methane is incredibly flammable. It's even burnt by hobs so that we can cook food. To find out, researchers at Cornell University took all of the ingredients that we know are present on Titan and mixed them up. Not in a test tube though, this isn't Breaking Bad, but in a supercomputer. Even without water, they were able to make a cell membrane, essentially the outside wall of a cell, the building block for life. Now I know the dream is to see some great big tentacled monster like rising up from the methane oceans. I mean, realistically, we're looking at something like microbial life, but that still will be incredibly cool because it will be completely different to anything we have on Earth. It will be entirely and 100% alien.
We tend to think that life would look like us. You just have to look at the Star Trek movies. All the aliens kind of look like insects and things that we already know. But why not be something completely different? Something that we can't imagine, but something perfectly suited to the conditions that are on Titan.
I grew up when Star Trek was just coming out, and it was an inspiration to me. But the key moment was when I realized that the job I wanted was not Kirk's job, but Spock's job. He's the one with the tricorder. He's the one that's detecting life. And my favorite saying is, it's life, Jim, but not as we know it.
Now, one place we've been looking for life for a long time is the surface of Mars, because although it's barren and dry today, once upon a time, it was covered in an ocean of water. Incredibly, traces of that ocean do still exist today. 4.5 billion years ago, the Martian Ocean covered 19% of the planet's surface and was as deep as the Mediterranean. That was until solar radiation bombarded the planet and stripped it of its protective atmosphere, and the water ended up freezing into ice caps on the poles.
Mars was a water world. It would have been better to characterize it as a water world, whereas now, of course, it's a desert world. But it's that water world that's interesting. That's the world that may have had life, and that's the world we want to investigate.
And crucially, it looked how the Earth looked when life first started on Earth. So if life could have started on Earth, then what's to say that life couldn't have started on Mars? Mars isn't the only place that's getting scientists who are on the hunt for alien life excited. The one I'm really rooting to have life on is Enceladus, which is a tiny moon of my favorite planet, Saturn. It shocked us all when we found out that it had water plumes just pouring out of its south pole. It wasn't just spewing out of one crack on the surface, but 4 huge fissures that were each larger than the Grand Canyon. That amount of water could only mean one thing. Enceladus had to have liquid oceans under its surface. And it's not just Enceladus. High on the list of places that we'd expect to find alien life is Jupiter's moon, Ganymede, the largest moon in the solar system. Scientists managed to discover that there was an ocean 100 kilometers deep, 10 times deeper than any ocean on Earth, that was encircling the entire moon. Each new ocean discovered gives a little bit of a boost to our chances of finding life elsewhere in the solar system. But could any living thing survive the extreme environment of space and other planets lacking protective atmospheres? Creatures on Earth could give us some idea. Meet this little fella. This is a tardigrade, sometimes known as a water bear or a moss piglet. Moss piglet! They're just too cute. These are aquatic, so you'd expect them to die if they weren't in water, but they actually have a very special ability.
As that sample jar starts to dry out, as that specimen starts to dry out, what's cool about these guys is they can survive that extreme desiccation, drying down to like a crispy little booger.
Now, they might look dead, but as any 90s kid knows, a lot can happen if you just add water.
It's not really dead, because when we add more water to them, when environmental conditions are good again, they can come right back alive.
This ingenious hibernation mechanism makes them one of the most resilient creatures on Earth and means they can survive some really extreme and changeable conditions just like those in space. They have even reanimated after years spent frozen in the intense cold of Antarctica, and they can withstand incredible pressure and even survived being shot out of a gun.
It's mind-blowing, dude.
I guess they're like the Han Solo of the microbial world. Like, these things could totally survive being frozen in carbonite as well.
Took them into space, put them on a satellite, opened up the door, set them outside, exposed them to extreme temperatures, vacuum, right? Hot, cold.
Huge radiation. And then when they brought them back to Earth, they did what you're seeing here.
Like a machine, man. Yeah. You add the water to it, they take them up, cells start to do their thing again. And they come back alive. It always blows my, look, I'm an old fat dude and I've looked at these 100 times. Thousands of times, millions maybe.
You're not that
man,
old.
well, and then when I actually look at them under the microscope every single time, I'm like, dang, that's cool, man.
What's clear after finding all of these other oceans elsewhere in the solar system is that we can't claim to be the only blue planet anymore. But I'm more excited for the day that we can say that we know that we're not the only place in the solar system that has life.
It was really a wow moment. There was liquid water elsewhere in the solar system. We had been right. You have all of the ingredients that you need, that we know of, to develop life as we know it.
We have cleared the tower, and the Cassini spacecraft is on its way to Saturn.
So these sort of hard cases, these James Bond-looking cases, are used to transport the flight hardware. This is one of the magnetometer sensors that I worked on, and it will have been integrated onto the boom that came out from the side of the spacecraft.
And here's part of the magnetometer instrument, and here's the other half of the magnetometer instrument. This is a quarter-size model, so this is a quarter-size me. I'd like to be this weight, not this height.
She was one of the best things about the Cassini mission, because I spoke to her on the phone every couple of days for years and years and years. So a gas giant like Saturn is incredibly mysterious.
Saturn just captivates people because it looks so supernatural. It engenders the immediate feeling that it can't possibly be real.
It has no solid surface, and it has rings around it, and we don't necessarily know where those rings came from or how old they are.
These, as you can see, are spiky shadows that are created by these features here that are sticking up 2.5 miles.
Having the perspective of Cassini to be able to see that was one of the most extraordinary things, I think, about the images that came back.
It was just extraordinary. It was out of science fiction.
Some of the most amazing discoveries that Cassini made were about Saturn's moons. The first flyby of Enceladus was not terribly close, but something funny was happening in the magnetometer data.
Okay, so put it into slideshow.
My boss came to the team and said,
"You can see there's a little pimple in the data, just over there.
This looks intriguing. This is not what we expect. We expect on a rocky moon for the magnetic field to drape over it, a bit like a nice peaceful curtain draping over a window that's not moving. And instead it looks like there's some sort of breeze gently fluttering that curtain."
And what we were able to do is calculate what ions were generating those waves, and it was water group ions.
So Michelle decided, after discussions with all of us, that she would go to the Jet Propulsion Lab and she would propose moving the next flyby of Enceladus, which wasn't for some time to come, to much sooner. And this was a huge risk for her.
We knew for us to be able to have a chance of really seeing what was going on at Enceladus, we needed to get closer.
The principal investigator of the magnetometer, God bless her, she went into action and convinced the project to take the spacecraft close to the South Pole so we could all get a better look.
And I must confess, I didn't sleep for 2 or 3 nights before that close flyby, because if we hadn't seen anything, no one would ever have believed anything I said again. So, but what we found was spectacular.
This image made me nearly fall off my chair, because here we see dozens of jets, big and small, coming off the South Polar region.
It was fantastic. It was really a wow sort of a moment. There was liquid water elsewhere in the solar system other than the Earth. Enceladus, tiny rocky moon of Saturn, is geologically active. A stable liquid environment, organic material, and contact with rock, you have all of the ingredients that you need, that we know of, to develop life as we know it.
I love this picture, and it's about as much meaning as you can get out of the Cassini mission, because we know that that moon has an ocean in it that could harbor life.
One of the mysteries of Saturn originally was the source of the rings, and it turns out that Enceladus's geysers feed the very faint but very wide E-ring. It shouldn't be surprising that we found such interesting geological activity on a planet with 82 moons. Ironically, all these wonderful discoveries that we made meant you run out of fuel. It was on 1%, it had an empty tank, so we had to crash it into the planet and let it go.
This is the start of the end of the mission. We're running out of fuel, and we're going to make sure we go out with as much great science as we can.
We want to see how much of the atmosphere we can see before we lose the signal, before it can't fight the atmosphere anymore and it goes off point.
These last grand finale orbits where Cassini dove between the rings and the planet, they were never foreseen in the original mission planning. Actually getting to do that was really remarkable. Take these kind of dangerous dives between the rings and the planet to see what that space was like, actually with the spacecraft physically being there, was really remarkable.
In some ways, I just want it to be over now. You know, you're sort of waiting for it to end, and it's really weird.
Quite a lot of us were gathered round, tensely waiting for the data to come back. We were relying on the commands that we had written and we had sent to the spacecraft to have worked properly, and for the spacecraft to continue to be able to talk to us right up to the very last minute.
I can confirm science playback is unlocked.
And then it'll go away. We'll lose the signal, and that'll be end of mission.
Cross for 0 time.
So that would be the end of the spacecraft. Project manager off the net.
It doesn't feel a long way away, actually, because every time I watch it, I am immediately there again. So that I guess says something about the impact that the end of mission had.
That was a great spacecraft. It did exactly what we asked it to do, all the way to the end.
When you have checked on a spacecraft every day for more than a decade, and then suddenly it's not there, it really is a wrench. It's a blow, and you feel sadness and a certain amount of grief.
Godspeed, think it and release it.
Ever wonder what would actually happen if an alien civilization made contact? If they haven't already? Would the public be made aware, or would it be kept secret? How would we decode what they're saying? And how on earth will we reply? Well, believe it or not, there is an entire field of science that is dedicated to this.
By sending intentional messages, we'll let the civilizations know that we want to make contact.
There actually is a protocol that tells us what to do in case we pick up a signal that looks promising.
It's time to explore the unexplored. Seth Shostak is a senior astronomer at SETI, the rather cunningly named Search for Extraterrestrial Intelligence Institute. For decades, the institute has been leading the way in actively searching for extraterrestrial signals, in the hopes of making the first contact with ET.
Most people, when they think of looking for intelligent life, they have some scenario kind of like in Star Trek, right? You get to a fancy rocket and you just, rocket off to some other world and look for it. We simply can't do that. But what you can do is maybe find the aliens at home by eavesdropping on their radio waves, or maybe they have flashing lasers.
If alien civilizations are anything like us, then they'll emit plenty of signals all the time. Radio, television, microwaves. All we need to do is just eavesdrop on one of these signals, and then boom, we've got contact. To make this possible, SETI uses 42 radio telescopes called the Allen Telescope Array. They direct these telescopes towards clusters of stars that we know have exoplanets, in the hopes that one of those exoplanets is broadcasting signals.
Now, we're looking for signals that are what are called electromagnetic signals, which is to say, flashing lights or radio waves. I mean, radio is just another form of light, if you will. So that's what we're doing. And why do we do that? Well, we know that it would work. We know that signals like those could go, from one star system to another and not become so weak that you could never detect them. I mean, it's always possible that they've developed some new physics that allows them to communicate in a way quite different from what we're envisioning. But, you can't do an experiment based on science you don't yet know. So we go with what we do know.
They haven't found anything definitive yet, but what happens when we do?
A lot of people do think that there's some sort of official procedure if you find a signal. I mean, wouldn't the Pentagon get involved and so forth? Well, they've never shown much interest in getting involved in it. And asking for a procedure is like asking Chris Columbus, hey, Chris, look, you're going to get these 3 ships and head west on the Atlantic. What if you discover a new continent? Have you got a protocol for that? Well, he didn't, and it wouldn't have helped anyhow.
Are you as surprised as me to hear that there is no official protocol for when we receive alien signals?
Now, people who are involved with SETI tend to think ahead. There actually is a protocol that tells us what to do in case we pick up a signal that looks promising. It's very trivial. It just says, check out this signal, tell everybody, and don't start broadcasting back until you have the you know, the consent, if you will, of the rest of the world's population. So you don't have one society trying to monopolize communication with the aliens. What would happen after that is you would get everybody in the world who can study this thing because they got a big antenna or whatever. Then they would build new equipment that might be able to get the message. In other words, the bits that presumably are attached to that transmission. And once you have those, now you have, you know, the equivalent of the hieroglyphics, and now you try and figure out what they might mean.
Bear in mind, these might not be intentional messages. We could be picking up their equivalent radio and TV transmissions that have just stumbled into our radio telescope. But for now, let's assume that they are sending a direct message. What happens next?
What if we decide to talk back? You know, how will we encode that? Will we send them stuff in colloquial American English, a language they always seem to understand in the movies, or what else? You know, probably it's better just to send lots and lots of information. I would just send them the internet myself.
Really? It's mostly video games, TikTok dances, and ASMR.
Replying to any signal that we might pick up is, actually, it's very controversial. You wouldn't think so, but it is. You know, what are you going to say? And there's some people say you shouldn't reply at all. So, you know, the matter of replying is controversial because of this potential for some sort of danger. On the other hand, I'm sure that if we were to pick up a signal next week or next month or next year, there are going to be plenty of people who have the ability to construct a transmitter in a backyard dish who are going to be sending their own messages to the aliens.
That's more terrifying than sending the entire internet. But what's odd is if aliens exist and there isn't some mass government conspiracy, then why haven't we heard anything? Well, as SETI continues their search for extraterrestrial intelligence, there's another organisation that thinks that we shouldn't be waiting to hear from them, we should be actively sending signals to potential alien habitats. What would you call an organisation that messages extraterrestrial intelligence?
My name's Doug Vakoch. I'm president of METI International. For over 60 years, SETI scientists have been searching for signals from other civilizations. So far, we haven't found anything. But what happens if every civilization is doing exactly the same as us? It would be a very quiet universe. That's why we should be sending messages of our own to try to elicit first contact. I'm at a scientific facility far north of the Arctic Circle called IceCat, an organization that sends radar signals into the sky to understand the composition of our upper atmosphere. But the interesting part, the new angle, is that we can also use it to send signals to nearby stars. One of our prime targets is the nearest star to Earth, Proxima Centauri, which is orbited by a planet in the habitable zone. We're sending signals that communicate some core ideas of science like chemistry, the periodic table of elements, something that we and the aliens have in common. By sending intentional messages, we'll let the civilizations know that we want to make contact. And in some cases, that may just be what's required to get a response.
Whether you think we should just wait and listen or actively send messages out into the expanse of space, the search is well and truly on. We haven't yet found evidence of life outside the Earth, let alone intelligent life, but scientists do believe that there is life out there. And remember, these signals can take a really long time to transmit.
In the best case scenario, we could send a message and get a reply in just 8 years. That's how long it would take to communicate with the nearest star to Earth. More realistically, it could take centuries, even millennia to communicate. So this is an inherently multi-generational project.
So there may well be another planet 1,000 light years away whose messages are hurtling towards us. And it could be any day now that we finally hear from them. Or maybe they're just watching, listening, biding their time. Or if they're anything like us at all, they've been meaning to message us back. And they will, just after one more scroll.
The fate of the planets is intricately tied with that of the star that they orbit. So for our own solar system, the sun dictates our fate.
As our sun has changed, so has the potential for life on our neighboring planets. Their history shows that habitability is a delicate balance. That doesn't always last. There is only one planet that has retained its water and habitability, and that's Earth.
What's remarkable about Earth is the stability of those conditions, that Earth has been able to maintain oceanic conditions at its surface throughout its entire history, through billions of years, and that's what's facilitated the very rich biological evolution of Earth.
Earth is a very special place. It's the only place in the universe where we know definitively that there is life.
For that to happen, you need not just liquid water appearing on a planet, but liquid water staying on a planet, and that's the magic of Earth.
Thanks to the size and geology of our planet, the atmosphere has remained stable enough for billions of years, protecting the precious water that has enabled complex life to evolve. Life has woven itself into the fabric of the planet. And has shaped the continents and the oceans. So that now, life itself maintains the very atmosphere that protects our fragile ecosystems. But as the sun continues to grow hotter, temperatures on Earth rise. Upsetting weather patterns, raising great storms across the planet, and devastating droughts. As plants around the world die out, oxygen levels plummet. Around 1 billion years from now, the age of complex life on Earth will finally draw to a close.
Earth will ultimately be like Venus and Mars, just mostly CO2. There'll be nothing else really in the atmosphere. And it will remain in that state as a sort of hot oven planet until ultimately the sun, when it uses up its hydrogen and goes into a different phase, will become what we call a red giant.
You know, as we've seen in other stars throughout our galaxy, throughout the universe, our sun will continue to get hotter and hotter over time.
And at that point, it will expand greatly to the point where it will nearly engulf the Earth entirely. And at that point, the planets will lose their atmospheres and they'll be just sort of swept away.
As it exhausts its hydrogen fuel, the sun's outer edge inflates. As our star enters its red giant phase, expanding millions of kilometers out into space. Mercury is the first to be engulfed. Then Venus's fate is sealed. Some models predict that Earth may barely escape the fiery fate of its neighbors, hanging on beyond the edge of the dying star with Mars. the long era of the 4 terrestrial planets will be over. The lives lived on one of them, nothing more than a distant memory.
Right now, the 2 Voyager spacecrafts are hurtling through interstellar space at 35,000 miles an hour. The space is so far away that it took 35 years to get there. And now we need new science to understand it.
I couldn't believe how nature was fooling us.
It made us rethink everything we knew about the shape of our solar system.
I think I discovered that the tail has a croissant shape.
And even where the edge of our solar system actually is.
There was a lot of confusion. Actually, the confusion lasted almost a year.
Even just to understand what Voyager is trying to say requires a very special set of skills.
It's really like a Swiss watchmaker. It needs to be a trained eye to tell me, can I trust this data or not?
What's even more extraordinary is how Voyager, the old spacecraft from 1977 with 64 kilobytes of memory, was able to make this journey at all.
3, 2, 1. We have ignition and we have liftoff.
Both Voyager 1 and Voyager 2 were launched in 1977, and it had to be then, thanks to an extremely rare planetary alignment that happens once every 175 years.
Where we could fly past Jupiter, get a gravity kick, and go to Saturn, get a gravity kick and get to Uranus, and another gravity kick and go past Neptune.
Within just 2 years, Voyager 1 had reached Jupiter. Voyager showed us a planet, which looked so serene through a telescope, was actually rocked by hundreds of raging hurricanes, a glowing aurora at the North Pole, and 3 thin rings. Voyager took 33,000 images of Jupiter and its major moons that captured the world.
And we'd get to see these pictures and go, whoa, look at that, what's going on? It was fantastic.
On a night like tonight, our eyes, our minds, our souls, our blood are moving out through the universe. We're part of history, and that means that we have to replace the old myths with new ones.
Just 1 year later, and Voyager 1 had already sped past Saturn, spying intricate details in the planet's rings. From Earth, scientists could only see 5 or 6 of Saturn's rings. Voyager showed us that there were more than 100.
And I can remember those first pictures as we flew away, looking back at that system and seeing the reflected sunlight in that structured ring system was just so beautiful.
Then the Voyagers parted ways. Voyager 1 headed straight for the edge of our solar system. Voyager 2 took a more scenic route, reaching Uranus in 1986, and eventually Neptune in 1989, showing us yet more outstanding views of the green and blue planets, and spotted geysers on Neptune's large moon, Triton. And that was the main mission, the first human-made object to reach the distant worlds of our solar system. But the Voyagers weren't done yet. They were about to embark on the journey to search for the edge of our solar system. And before they left, there was one last thing to do.
Carl Sagan convinced NASA to turn the cameras towards Earth and take that very famous picture, the pale blue dot.
On that blue dot, that's where everyone you know and everyone you ever heard of and every human being who ever lived out their lives. It's a very small stage in a great cosmic arena.
These images were the last of 67,000 images taken by the 2 Voyager spacecrafts. Their cameras were then turned off to save power as they carried on their journey towards interstellar space, the boundary where our sun's solar wind ends and the rest of our universe begins. Problem was, nobody actually knew where it really was. Scientists thought that sooner or later, the charged particles that create solar wind were going to run out, and Voyager would enter a pristine environment of interstellar space.
We thought that would happen, maybe just beyond Neptune. But no, that didn't happen. Well, we said to NASA, give us a bit more money, another 5 years. Well, this kept happening year after year. NASA, please give us a little bit more money, a little bit longer, soon we'll be there.
As Voyagers 1 and 2 continued to move out into the outer reaches of the solar system, they remarkably continued to send very faint signals back to Earth.
And this is what makes it so interesting and so fragile. The whole instrumentation of Voyager was designed to visit the outer planets that have very strong magnetic fields. So now you're dealing with a signal that is almost at the noise of the instrument. And because Voyager was not designed for that, it's a miracle fit that all this team is able to go mine the data and pull out the signal and tell us what's going on.
Just 5 instruments were still operating on the spacecraft, and in 2012, more than 35 years since Voyager 1 left Earth, scientists started to see the first signs that they were crossing into interstellar space, through the boundary known as the heliopause.
Think about the heliopause as your walls of your house. This is what separates the environment that is dominated by the solar wind from environment that is dominated from other winds from other stars outside of our bubble, the heliosphere.
The expectation was that there would be a sudden shock, a burst of activity that would make it obvious we'd finally reached this sharp boundary. But the reality was much stranger. All of the detectors on Voyager were seeing particles suddenly appear, and then disappear, then appear and then disappear, and nobody had a clue why. These strange particles seemed to be coming from elsewhere in the galaxy.
Did we cross or not? The data was so confusing.
On one hand, Voyager was still being affected by the sun's magnetic field, but the particles were suggesting we had crossed.
It turns out what really tipped the scale in the team was the radio data.
The data was stored on the spacecraft using a tape recorder. So ancient technology, it's extraordinary. But it worked. And the data were gathered and sent back bit by bit.
And 6 months later, we turned to the radio station of Voyager, and guess what we heard?
These plasma waves, converted into sound that we can hear, were the final proof that we had crossed the boundary into interstellar space.
The first human-made object to venture into interstellar space.
Even more extraordinary than crossing the boundary into interstellar space was what the data said about the shape of the solar system.
I was tasked to create a computer model with all the physics that we know to kind of predict this shape of the heliosphere.
It turned out that the solar system's heliosphere is not round like you'd think. It has a tail from whizzing around the galaxy. And more than that,
I was finding that it has a croissant shape, 2 horns with a void in the middle. It was just a shock to realize that something such basic as the shape of our home is completely different.
And all of this was discovered by a small, extremely low-tech probe more than 10 billion miles away. And they're still going. In 2018, NASA's Voyager 2 spacecraft crossed the boundary. Finally, both Voyager spacecrafts, with their 1970s technology, had reached where no human-made object had ever been before: interstellar space.
There's very little material, very empty. Space can be very, very empty.
The environment out there is colder and denser. And of course it's dark. There's not a lot of light. You're far away from the sun.
Voyager has also discovered that our solar system's impact is much bigger than we thought before.
We would have liked to get to a region where the heliosphere doesn't influence anymore the interstellar medium. What we call a pristine interstellar medium. What we're measuring now is a medium highly disturbed by the sun.
The Voyagers are still sending us ever fainter signals, still teaching us new things about interstellar space, but they're running out of time.
We probably have 2, 3, maybe 4 more years of power to communicate with Voyager.
But there are still so many mysteries left to be solved.
What is the environment outside? What's happening to the nearby stars that are influencing our system and so on?
So one of the beauties of the Voyager mission, that it started as a planetary mission, gave us the first images of our planets, discover volcanoes in the solar system, and then it went to discover our heliosphere, our vast, regions of our solar system, and enter into the galaxy.
Long after their power has gone, the Voyagers will continue to rush away from us, monuments to human endeavour and exploration, heading out towards the stars.
Voyager will continue its little journey in the interstellar space, way past when we maybe as a species will cease to exist, when we might move to a different planet.
It'll keep going and going and going and going and going forever.
So this is sodium cyanide, highly toxic, but we use this material for our research for origin of life.
Cyanide is deadly. As little as 1/10 of a gram can be fatal. John's colleague, Jianfeng Xu, has been working with it for over a decade.
Just keep gloves on, don't eat it. That's for sure.
Mixing the cyanide isn't enough. It then has to be exposed to the conditions of early Earth.
I'm going to put this in the solar simulator. This machine just simulates the early Earth conditions.
Levels of UV light were much higher back then.
UV light is the energy to drive the reaction, and it's free energy from the sun. And we're going to use it.
Inside the machine, the cyanide combines and recombines, creating the building blocks of life.
After a few hours, we can detect amino acid, nucleoside precursor, lipid precursor. They're all very important biomolecules in life.
Cyanide may be the raw material needed to kickstart life. So finding an abundant supply is vital for John and Jianfeng's theory. And one type of location is more promising than any other. Impact craters. As a meteorite strikes, its energy superheats the atmosphere, generating huge amounts of cyanide. And it also melts the planet's crust, creating hydrothermal systems.
The meteor impact is really important for life to start.
John and Jianfeng's idea is that rainwater flowed down the crater walls, absorbing cyanide, and then was heated in hydrothermal pools at the bottom.
And reaction taking place then. So simple.
To prove their theory, John and Jianfeng need evidence. Chemical traces from one of these craters.
On Earth, it's simply not possible to find evidence of these environments because all of the impact craters of that period have been erased by plate tectonics.
Scientists still don't understand how life began on Earth, but they do have 3 theories about how and where it might have happened. Hydrothermal vents with chemical energy for early life. Volcanic pools could have assembled cells, and impact craters could have provided the raw material for life. But here on Earth, essential clues to solve the mystery have long been erased. To find them, scientists need to return to Mars.
Poor Uranus, it's got rather boring clouds, truth be told. So there wasn't a lot to see with the cameras.
Passing close to the planet, Voyager's sensors reveal why Uranus is so featureless. Temperatures here are the coldest of any world in the solar system. there's simply not enough heat to drive the storms seen on Jupiter and Saturn. Uranus is an entirely new class of planet. An ice giant. And more surprises were to come. Uranus has rings.
We knew long ago from telescopic observations the rings were there at Uranus. We didn't know their configuration or their shape.
Voyager begins to explore the ring system and spots something curious in the shadows. Two moons, Cordelia on the inner edge of the brightest ring, and Ophelia on the outer edge, help to organize the system.
Particles within the rings can be moved inwards or outwards as these tiny objects called shepherd moons, whose gravitational force can shape and sculpt the rings themselves.
But it's the orientation of the orbits of these moons and the rings themselves that singles out Uranus as the strangest of worlds.
Uranus looks bizarre. The rings, rather than looking like that when you look through a telescope, they're actually orbiting up and over the top of the planet. The whole thing is tipped like a spinning top.
This bizarre orientation hints at an unusual past. Since the beginning, everything in the solar system has been circling in the same direction. It begins with a vast cloud of material that orbits the young sun. Over time, the material draws together, forming each of the planets. Today, they all orbit the sun and spin on their axes in the same counterclockwise direction as that primordial cloud. Except for Venus and Uranus, which spin in the opposite direction. But Uranus is even stranger, because the entire planet is on its side.
This was a really strange system. So why is Uranus so tipped on its side?
If a roughly Earth-sized object smashed into Uranus late in its formation history, then that would have had the proper amount of momentum to basically knock it on its side.
And the collision may also help to explain another of Uranus's mysteries: why the planet is so cold.
That impact presumably relinquished all of that internal energy that the planet had when it first formed, and has left it as a relatively dead and sluggish world.
Much is learned during this brief encounter. But Voyager's strangest discoveries are yet to come. Most surprising is Mercury. The least explored of the rocky planets, because of the difficulty of getting into orbit around a planet so close to the Sun.
5, 4, 3, main engine start, 2, 1, and 0, and liftoff of Messenger on NASA's mission to Mercury. A planetary enigma in our inner solar system. Now going through the sound barrier.
Following a direct route to Mercury would be impractical. A spacecraft would arrive at such high velocity, it would need to haul a prohibitive amount of heavy fuel in order to slow down enough.
We just had spacecraft separation.
Grounded solids have jettisoned.
So Messenger controls its speed by stepping from one planet to the next, using their gravity to slow itself. Even so, Messenger still approaches Mercury moving so fast that it is forced to fly past the planet 3 times, slowing on each pass. Until after nearly 7 years of flawless navigation, it arrives safely in orbit. At last able to begin its mission, mapping Mercury's surface.
That first image ever acquired from orbit around Mercury was amazing. When it finally came in, it looked perfect. It looked exactly like we expected it to be. For me, that was the real moment when I realized that we had successfully made it into orbit and everything was working.
This pioneering voyage has led to a completely new idea of how Mercury may have formed. Mercury is the most cratered planet in the solar system, with many puzzling features that hint at a violent past.
Mercury has a very unusual orbit. If you were on the surface of the planet, you would actually have to go around the sun twice to get one full Mercury solar day.
Also highly unusual is the planet's disproportionately large core.
Mercury is basically a big ball of metal surrounded like a tiny bit of rock.
How do you end up with a planet that has so much metal inside and then almost none on its surface? That was a huge mystery.
And the major question is, why? Why is it like this when the rest of the planets aren't?
A clue to understanding these strange features was found in Mercury's chemistry.
So very soon after we got into orbit, we started to get chemical data back from the surface, and we immediately got some surprises.
The tiny probe detects volatile chemical elements in concentrations that no one had thought possible this close to the sun.
These are elements that go into rocks, but that evaporate at relatively low temperatures. And immediately told us that some of the older ideas of how Mercury formed could not be correct.
What Messenger discovered about Mercury could suggest a new twist in the story of the solar system. Just a few million years after its formation, the young Mercury is seething with the heat of its violent birth. Slowly, a crust forms, rich with volatile elements. If it had been close to the sun, these elements would have evaporated before the rock hardened. So what could explain why they're so abundant on Mercury today?
The orbits of the planets and their current locations have changed over the history of the solar system. So where things are today doesn't mean that's necessarily where they formed. They could have and probably did move from different locations to where they are now.
One possible thing is that Mercury didn't form where it is today. It formed much closer to the other planets, maybe even outside of Venus or Earth, or somewhere in between there.
If Mercury had formed near Earth and remained at a more comfortable distance from the sun, its destiny could have been very different. But it wasn't to be. So what turned it into the strange, sun-scorched world we see today?
We don't know the full story. What we have right now are theories, and as we have new observations, we are trying to change everything to fit those observations.
Messenger's evidence of the volatiles on Mercury's surface and the unusual size of its core suggest an interesting new theory. It's possible Mercury began life as much as 160 million kilometers further from the sun than it is today. In the region of space where the young Earth is also forming. A region with scores of planetary embryos all fighting for position. In the chaos, it's possible that something large pushes Mercury off orbit and in towards the sun. Mercury brushes against another planetary embryo. This glancing blow removing much of its crust and mantle. Now little more than a metallic planetary core. Mercury continues toward the sun. Ending up in the peculiar elliptical orbit we see today.
Before we sent the Messenger mission to Mercury, I think we had a very simplistic idea of what it was going to be like. And Mercury turns out to be a more complex place with a more interesting and complex history than we had previously imagined.
But of course, all things have to come to an end, and once we were out of fuel, we could no longer burn our engines to keep from crashing into Mercury.
And sequencers, Chief Launch Conductor on. Engine verniers continue on, so look good.
After 4 years of observations, Messenger's fuel finally runs out. And the spacecraft adds yet another crater to this tiny world, where any prospects for life were scorched away when it was thrown too close to the sun.
We're guaranteed to find an identical copy of our whole universe, as well as countless variations where things are similar to here, but still different.
Multiple universes now are a genuine possibility, which begs the question, is there another you in a parallel universe? Now, it probably doesn't surprise you that studying parallel universes was once considered completely bonkers in the scientific world, and it even alienated people who decided to pursue it.
When I was a grad student, I used to secretly print out my multiverse-related papers.
This job was the only job I was ever interviewed for. I was on the verge of having to drive a taxi cab.
Now theoretical physicists have realised that parallel universes are possible, mathematically at least. So why do we think other universes exist? Now, one of these reasons comes from the weird world of quantum physics.
The important thing to remember about quantum mechanics is that it's weird.
It really is weird. It's the study of subatomic particles, the building blocks for every single thing around us in the universe. And what it tells us is that these particles can be both particles and waves, but crucially, they can be both at the same time, which splits our reality, giving us multiple different universes.
The idea here is that when you make a measurement of a particle that's here and there at the same time, and you find the particle over here, then there's a you which finds the particle over here in this world, but at the same time, there's another world over there where another you has found the particle over there. And both of these worlds are equally real. So the quantum multiverse is not separated from us by distance. It's not someplace very, very far away. It's someplace that's effectively here in space, but the complexity of the quantum dynamics prevents these different branches from talking to each other. Whether you like it or not, the fact that we live in a multiverse is the dominant scientific paradigm. Suck it up.
Another theory is one of mathematical inevitability. If our universe is made from a finite amount of simple matter, then it follows that other universes are made in a very similar way.
Just as this house is made out of fundamental building blocks that we call Legos, everything in our world is made of fundamental building blocks we call elementary particles. And if you have some random process arranging elementary building blocks in a finite volume, there are of course very, very many different ways in which it could do this. And that means that if this process repeats in an infinite number of other volumes of the same size, then we're guaranteed that eventually it's going to create every possible arrangement. We're guaranteed to find an identical copy of our whole universe, as well as countless variations where things are similar to here, but still different. Even a Max over there who's identical to me, not just in his physical appearance, but in that he actually feels that he is me.
Another theory called inflation describes how the universe expanded exponentially in the very first tiny fraction of a second after the Big Bang, but with some areas of space expanding faster than others, creating bubbles or pockets of space-time where other universes could have formed. If this idea turns out to be right, then it could mean that these pocket universes developed with their very own laws of physics. So there could be another you in those universes that's able to walk through walls or fly through space. So if our universe is not alone, the question remains, what would the other you be like? Well, according to quantum theory, there's a new version of you and a brand new universe made with every single decision you make.
So every time I flip a coin, say heads or tails, that is just some little quantum accident. The universe is splitting into two worlds every time it comes up heads or tails. So our experience of this splitting is like the experience of walking through a garden of paths that fork. When we come to a fork in the path, we take one or the other, heads or tails. But both forks exist at the same time. We only experience one of them. There are literally gajillions of universes out there, of which ours is only one.
Then there's the patchwork model, a near identical copy of our own universe, just made elsewhere. In this kind of parallel universe, there's another you that's very similar, just with subtle differences.
We're guaranteed to find countless variations where things are similar to here, but still different. The dinosaur-killing asteroid that was our lucky break missed Earth, so there are no humans, just dinosaurs in Winchester today. There's another one where I didn't make it as a physicist, but I'm actually enjoying life working as a bartender. Then there's a whole bunch which are very similar, where I just chose to dress a little bit differently.
These ideas all point towards multiple weird and wonderful universes existing out there. But with scientists not able to see the entirety of our own universe, how on earth can we prove that these other universes exist? Scientists think that they might be getting a little bit closer.
Truth goes through 3 stages. First it's ridiculed, then opposed strongly, and finally it becomes self-evident. Perhaps now we are reaching the stage of self-evident.
Scientist Laura Massini-Horton found something really weird. She found evidence for what appeared to be 2 universes crossing over.
The detection of the cold spot was one of the signatures that we predicted by tracing forward the quantum entanglement of our universe with all the other surviving universes. We predicted that there should be a large area in the sky of about 10 degrees, and indeed that's what was observed about 7 months after we made the prediction.
Recently, there's also been a big leap forward for inflation theory, which predicted that if this rapid expansion of the universe happened, it would send ripples out into the universe. We call these ripples gravitational waves. We'd never detected anything like this until 2015, when 2 experiments called LIGO and Virgo managed to detect gravitational waves coming from the merger of 2 black holes. With that detection made, it makes it more likely that we might be able to detect gravitational waves from inflation. But why should we really even care about figuring out if multiple universes exist? Well, it actually feeds into the age-old question of what is our universe expanding into? If other multiple universes exist, perhaps our universe expands as neighboring ones contract. And this could actually tell us more about our own universe, and especially how our own universe will end. Perhaps eventually we will expand until those other neighboring universes also then have a big bang and start expanding into us, which means that we then start contracting. And perhaps our universe will end not in a big bang, but in a big crunch. Rain made of diamonds and ruby gemstones, 2,500-degree clouds filled with hellish liquid lava, and 350-year-old giant megastorms. This is the most extreme weather in the universe. Saturn is the 2nd largest planet in our solar system, and its rings make it instantly recognizable, and personally it's my favorite planet because it rains diamonds from its clouds. Scientists estimate that around about 10 million tons of diamonds are produced in Saturn's atmosphere every single year. Now the sizes of those diamonds could vary a little bit, but they're estimated to be about 1 centimeter across. That's the size of a 4-carat diamond. But why does this happen?
We know that on Saturn there's carbon soot. The carbon soot is created by lightning. Lightning actually zapping methane in the atmosphere. The carbon soot precipitates or falls through the atmosphere.
As the carbon soot falls from the clouds, this same crystallization process occurs, but instead of taking billions of years, it happens in a matter of moments. Now, in order for a planet to have weather, it needs an atmosphere, the layer of gas that surrounds a planet. So for example, Earth's atmosphere is made of nitrogen, oxygen, argon, and a little bit of water vapor as well. The planet Mercury and our moon, on the other hand, they don't have an atmosphere, hence why they look like grey, lifeless rocks. On Earth, a cloud forms where it's too cold for water to stay as a vapour in the air. Now that can happen with other materials too, just at different temperatures. So it's essentially possible to have a cloud made of anything. But what about planets that are so hot that things that exist as solids on Earth are actually liquids and gases in their atmospheres? I'm talking about things like rock and lava. Imagine it being so hot that lava evaporates into the air, forming clouds, and then you get lava raining from the sky. 55 Cancri E is an exoplanet that's about 40 light years away from us. It orbits really close to its star. Not only that, it's also tidally locked, which means that one side of the planet always faces its sun and it's always daytime there and it's boiling hot. The day side is permanently covered in an ocean of molten lava. It can be hard to picture what lava rain would actually look like, but volcanic eruptions here on Earth in places like Hawaii give us a hint of what it might look like.
Right here was the site of a massive eruption. All along this fissure, fountains of lava shot into the air nearly 100 meters high. The liquid lava droplets then cooled and solidified in the air before raining down onto the surface as these tiny pebbles. This is what we think the rain might be like on planets like 55 Cancri E.
Planet hunters and astronomers think they've found an exoplanet with the strangest rain in the universe. WASP 12b is an exoplanet 12,000 light years away. It's a gas giant like Jupiter, but it's twice as big and its atmosphere is 2,000 degrees hot. An atmosphere like that, we think the conditions would be just right to give us molten ruby rain.
And the way that it scatters light suggests that there are clouds high up in the atmosphere. At this part of the atmosphere, the temperature is around 2,000 degrees. So the most likely substance forming these clouds is an aluminium oxide called corundum, which forms the basis of rubies.
This crazy extraterrestrial weather doesn't stop at gemstone rain. There are planets out there that have the most gigantic storms that humankind has ever witnessed. We have Mars rover footage that shows us dust devils that are over a kilometre high. But impressively, the storms on Mars can reach up to 20 kilometers in altitude, and it's all down to Mars's atmosphere.
Its atmosphere is 1/100th the pressure of Earth's, and the effect of having that really low atmospheric pressure on Mars means that it can't trap any of its heat. So Mars is a cold, barren desert compared to Earth or to Venus.
The dust storms are so bad on Mars that every few years or so they engulf the planet for months at a time. That's going to have a major impact on any future human missions that we send to Mars. These storms on Mars, though, are minuscule in comparison to what's been observed elsewhere in the solar system. We've sent probes and satellites to all of the gas giants and found some mind-blowing weather activity. The Great Red Spot is a storm on Jupiter that is twice the size of the entire Earth. It was first spotted by Giovanni Cassini through a telescope in 1665, which means it's been raging non-stop for at least 350 years.
That makes it the longest living storm that we know of. The outer planets are big balls of gas, and that makes a huge difference in the weather because you don't have continents, you don't have mountains for the winds to rub against, and there's nothing to control the weather the way the continents partly control our weather.
Saturn is the planet with the largest and most powerful storm in the solar system, covering 4 billion square kilometers. And we know about it because we've seen satellite images of it growing.
On December 5th, 2010, the radio receiver on Cassini started picking up the radio signal of lightning. And on the same day, the camera saw a little storm up in the northern hemisphere of Saturn.
Within 6 months, the storm grew so large that it wrapped around the entire planet and its head caught up with its tail. The truth is, life on Earth is a huge anomaly in our solar system, our galaxy, and even maybe across the entire universe. The majority of other planets are a lot less inviting.
So the planets that we've found so far aren't particularly nice places to go. They're not somewhere you'll put on your vacation list anytime soon.
So while we might not describe weather here on Earth as mild all of the time, astronomically speaking, mild is the most appropriate word. What makes Earth so habitable is this perfect mix of conditions that we have that essentially make it like a Goldilocks planet for life. And that includes our proximity to our star, the sun. Any closer and it would be a hellish inferno, and any further away it would be a frozen wasteland. So it could just be a matter of time before we find a planet that's similar to Earth. But what we do know is that warm, cold, wet, dry, windy and mild, all of these conditions work in perfect unison to keep us alive here on Earth. Essentially, we got lucky. So think about that the next time you want to moan about the weather.
This tiny little moon, 500 kilometers in diameter, has proved that it can surprise everybody. Water vapor plumes with organic material coming out of this tiny little moon, who would have thought? I get asked whether Enceladus is my favourite moon, and at the moment it is, partly based on the observations that my team made and the discovery that we made at Enceladus. So the Cassini mission was the first spacecraft mission to orbit around Saturn and its moons. It was also the first mission to taste what was in an extraterrestrial ocean. The mission kept being extended and extended, and so in the end the mission lasted for 13 years. The discoveries were pretty radical. We were flabbergasted, to be frank. I think for me the most surprising discovery that was made was this water vapor plume at Enceladus, which we then followed up with discoveries about a liquid water ocean, under the surface a heat source, organic material. I've now given away all the secrets. My team and I changed the course of the mission because this was a team effort. So we had 3 flybys of Enceladus, and 2 of these flybys were quite distant flybys. In the data that my instrument took, so data from the magnetic field in the environment of Enceladus, we saw some strange signatures that we weren't expecting to see. And what those signatures were telling us was almost as if Enceladus was a bigger obstacle, a bigger body than it looked. We thought maybe we hadn't got the trajectory of the spacecraft back properly, so maybe we were seeing an artifact in the data. But the fact that we saw it on 2 separate flybys meant that we said, okay, we thought we were seeing something. So I actually traveled out to the Jet Propulsion Lab, and I was planning to make a presentation to the project, because what I wanted to do was I wanted to persuade them that we thought we were seeing this really strange atmospheric signature, and that it would be really good to go close on the 3rd flyby. And I was really nervous, because if the flyby changed, that meant all of the plans that we had made for the last 6.5 years would have to be changed, and some instruments would not take the data that they'd planned to. But the possibility that we would discover this water vapor atmosphere at Enceladus was exciting enough that the majority of people decided it was worth a go. It was extremely nerve-wracking waiting for that 3rd flyby. So, you know, I'd essentially put my and my team's reputation on the line. And so I must confess, the 2 or 3 nights before the flyby, I didn't sleep very well. I tossed and turned a lot. Because if they hadn't found anything, no one would ever have believed anything I said again. You know, every once in a while you have to be brave and you have to say that you think you're seeing something, but luckily they found something. When we had that third flyby, what we found was, instead of there being an atmosphere covering the entire surface, there was simply an outgassing of water vapor from the South Pole. In addition to that, because we went so close, all of the other instruments were able to take fantastic data sets as well. And what we found is there were cracks at the South Pole through which this water vapor was escaping. There was an internal heat source. There was organic material. And so that meant we had 3 of the 4 things for potential habitability to form. You need a heat source, you need liquid water, you need organic material, and then you need those first 3 things to be stable enough over a long enough period of time that something can actually happen. So that's when there was a real focus on Enceladus for potentially being a place where life or habitability might have been there in the past or might be able to form in the future. The coming together of all of the Enceladus data and the discoveries that were made underpins what I think is one of the most important discoveries that has been made in planetary science in the last 30 years. And that is that you don't need to look close to the sun to find liquid water. You can be quite far from the sun, but you can find liquid water. It's just not on the surface, it's underneath the surface. And so that's been almost been a sea change in planetary science. We now have a much better understanding about Enceladus and its internal structure. So we have a global liquid water ocean underneath the surface of Enceladus, and the surface is made up mainly of water ice. Biggest unanswered questions for Enceladus are, why is there only a water vapor plume at the South Pole? We still don't quite understand why there's a heat source, because the fact remains that it was formed billions of years ago. Because it's so small, it should have cooled down. And so we think it might be linked to its orbit around Saturn. So if the orbit around the moon is not completely circular, then on some parts of the orbit it's closer to the planet than on others. And when that happens, tidal forces keep the interior warm. I think Enceladus will always be memorable for me, because in some ways it was my way of becoming confident in my ability to persuade people, but also confident in my team and what we were able to do with the data. That's probably why it's my favorite moon. Depending on what we discover at Ganymede, it might move slightly down my list. For me, it was almost a coming of age for my team, but also for the instrument. You know, people say to me, why do you explore planets? And for me, we are explorers. Humankind have always been explorers. When we didn't know much about the Earth, people would take ships and go to what some people said was the edge of the Earth, and they were scared they're going to fall off. For me, exploring planets is part of that exploration. It's what we do. My first view of Saturn, actually, was through a telescope that my dad built. I saw Saturn and its rings. Didn't see any of the moons because Saturn is so far away, but we were able to see the rings clearly, and we also saw Jupiter and some of its moons as well. So I never thought back when I was a child that I'd end up doing what I do today. I will never forget Enceladus. In planetary science, it will always be an important thing, and it will be an example that people refer to in the future as well.
Who owns Mars? It's a surprisingly big problem. With the USA and China planning to send humans by the 2030s, and with private company SpaceX potentially sending them by 2026, it's gonna get pretty crowded up there. You can even go online and buy a bit of Mars yourself. I've got mine. So who owns what up there? And what happens if things get nasty? I think we're gonna need a space lawyer.
It's time to explore the unexplored.
Space law sounds like a fantasy job, but it does kind of make sense. Surely there must be some kind of rules and regulations. Well, yes, and it started in 1957. The US and the Soviets are in the midst of a Cold War. They're sworn ideological enemies. Suddenly, the Soviets launch Sputnik, the first ever human activity in outer space. It flies around the Earth a few times, including directly over the US. And that raised a whole bunch of new questions. If an enemy vehicle enters your airspace, then you can shoot it down. But suddenly people had to think about where does airspace end and space begin? The prospect of war in space was so frightening, they decided to keep the war on terra firma. To the surprise of the rest of the world, they joined together and drafted the Outer Space Treaty. Finally, it's over to the space lawyer.
The most fundamental baseline principle is found in Articles 1 and 2 combined, which basically makes outer space into a kind of a global commons, an international area, legally very similar to the high seas, and no single state can act as if outer space or part of the outer space or even part of the moon is part of their national territory. It's basically open for all states, and freedom for states to be active there is the bottom line. The drafters of the Outer Space Treaty were basically concerned with two elements, if you will. One was the military use of outer space, and then a secondary subsidiary level about science. The treaty didn't really discuss things which we are confronted with today as questions, at least theoretically, like the settlement on the moon or human settlements on Mars.
So it's good that states are free to use space, even if they weren't thinking about settlement. But that wasn't the only thing they weren't thinking about in 1957. The treaty only refers to political states. It doesn't even mention private companies. So does that mean that the billionaires of the world are exempt from the treaty?
One of the clear drawbacks looking back at the Outer Space Treaty was the absence of any detailed reference to the private sector. So what you see in the Outer Space Treaty is only one almost fleeting reference to the private sector in the guise of what they call non-governmental entities. But at the same time, it made sure that the state, in this case the United States or any other state, where those activities belonged to, was the one being responsible. And then Article 7 followed that up with also liability. So not only you as the United States will be responsible for them, for whatever they do, and you will be liable for any damage they caused by doing that. So the United States cannot dodge any international responsibility just because SpaceX or Virgin Galactic or Blue Origin does something in outer space.
Okay, so I get that ultimately states are responsible for what private entities do in space, how they operate, and any damages. But what about the use of land on Mars? We're planning on building habitats and living on Mars. Is that even allowed?
So we have to make a very fundamental and important distinction between, on the one hand, the prohibition for any state to own part of Mars. On the other hand, the freedom of outer space activity, which is the other part of the global commons thing, also means the freedom of simply establishing a habitat, putting space objects there, which then serve as houses, or probably even excavate minerals locally and build a habitat from those minerals. That all is in principle, again, allowed. And of course, there is a tension between those two, because it is one thing to be allowed to land somewhere, to put people down somewhere, maybe to have them live there for 25 or 30 years. But at what point in time should we say, wait a minute, now we are moving to something which looks too much like a real colony, which is prohibited by the Outer Space Treaty? But again, that question has not been solved yet.
But it's not like here on Earth, where if you break a treaty, we can physically take action. Mars is over 300 million kilometers away. So if the USA or Russia or China or a private company starts breaking the rules up there, wouldn't it be pretty hard to stop them?
Next question is then, of course, what happens if a private entity disregards the international rules of space law? Well, if that happens, then of course the first line is that the operator who goes beyond the terms of the license will be held criminally liable under the laws of his own country. It becomes a little bit more complicated at the second level when we go to the international arena. Either these states have to agree to a tribunal, or they have to sort things out on a diplomatic level. And of course, then the reality of the international community kicks in, that the bigger you are as a state, the more you might get away with.
These are all crazy scenarios that could arise in the future. And talking of the future, many people see Mars as a future second home for humanity. But how would our laws on Earth work in space? And if no country is allowed to claim sovereignty over celestial bodies, then how will it be governed if there are communities and multiple generations of Martian people?
But of course, at some point in time, certainly when they start living there, knowing that they will never return to Earth, when they probably get babies there who have never been on Earth for any part of their life, there will be a tendency for those quote-unquote colonies, I prefer to use the word settlements actually, to say, well, we don't want to be ruled by this earthbound state anymore because they have no idea what it means to live on Mars and to be safe on Mars. So we want to create our own legal regime, and sooner or later that may actually become, we want to create our own state. I often compare this with the Pilgrim Fathers who went to North America and then after a number of years said, well, why are we still paying taxes to the British King in faraway London? So it took a war of independence before the United Kingdom finally accepted, okay, let them be on themselves, let them be their own state. I just hope that when that happens in space, we are more peaceful as terrestrial states in allowing those to go out on their own. But that's still decades away, if not much further.
If my first chat with a space lawyer has taught me anything, it is that there is still a lot of grey area in space law. If we want humans to play nice on Mars, then we're going to have to answer a lot of these unresolved questions. And if you're silly enough to have fallen for one of those bogus websites that claims that you can buy a piece of land on Mars, well...
The paper is just worth the paper it's written on, and it doesn't give you any title. Don't expect to reap any benefits from it.
We're used to seeing NASA fire up its rockets and launch billions of dollars of equipment into space. But what happens when it messes up?
The Hubble Space Telescope project has suffered yet another setback.
And how do you fix a billion-dollar mistake up in space?
I did not have a line item that says NASA put wrong mirror in telescope.
With engineers needing to fix it not once, but twice.
So the summer 2021 event was a pretty intense anomaly.
This is the story of how the Hubble Space Telescope nearly destroyed NASA's reputation, and the retired engineer that helped bring the telescope back from the brink both times.
When I received the call, I was honored that they would think of me to try and help them resolve this.
This is electrical engineer Ron Barish.
I started working on Hubble in 1987, approximately 2 years before launch.
Hubble was one of the most ambitious space projects the world had ever seen. NASA had spent hundreds of millions designing a massive mirror in the telescope to get the sharpest pictures of the universe ever seen. Expectations were high. It promised to catapult space science into a radical new era, and all eyes were on it.
And liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
It was very exciting to watch the launch.
You have a go to open the doors.
And even more exciting to verify that our system was functioning flawlessly when it was turned on in orbit. Very exciting.
NASA was quick to champion it as the greatest advance in astronomy since Galileo. But then disaster struck.
The Hubble Space Telescope project has suffered yet another setback. Engineers have discovered that the giant telescope has a warped mirror, which means the images sent back to NASA are distorted. The pictures are little better than those from ground-based telescopes.
We found out that there was distortion in the image. Well, the images I saw were blurry. They called it spherical aberration.
When light enters the telescope, it's reflected first by a large 8-foot mirror, onto a smaller secondary mirror, which concentrates the light onto the cameras. If either mirror is slightly out of true, the picture becomes distorted.
And that's exactly what had happened. The mirror hadn't been tested with the rest of Hubble. Had it been tested, the scientists would have seen that the mirror was ground incorrectly by just 1/50th of a human hair. Tiny, but enough to ruin everything.
Everyone on the project was very disappointed, and it was an embarrassment that we had spent so much time on the program and that there was a significant flaw. The news was not very kind to the project.
For the American taxpayer, they're not going to be happy.
Well, look, you launched this $2 billion white elephant. What are you going to do?
And the bad news kept coming, as NASA's reputation received blow after blow after blow.
Matter of fact, my sister said to me, you worked on Hubble? That's an embarrassment to the United States.
But despite the setback, there were still some that had hope for Hubble.
So do not write off the Hubble telescope. It merely means it's not going to be quite so good as expected until the repairs are carried out.
Replacing the mirror wasn't practical. So instead, Ron and the rest of the team created an instrument called CoStar, which would act almost like a pair of glasses, redirecting the light to account for the flaw in the mirror.
My job was to provide an electronics interface box called the Remote Interface Unit, CoStar.
3 years after Hubble's embarrassing start, they finally had the parts needed to fix the broken Hubble Space Telescope. All that was needed now was a team of astronauts bold enough and daring enough to attempt a mission of this magnitude.
There weren't very many of us in the office at that time who had done spacewalks, and so that's how I got kind of a quick turnaround from one flight to the next.
You know, in all the failures, the hundreds and hundreds of failures I came up with that I had to accommodate, I did not have a line item that says NASA put wrong mirror in telescope.
Catherine Thornton and Story Musgrave were two of the astronauts that were selected for the mission, and in 1993, they set off. The world held its breath as the astronauts carried out 5 back-to-back spacewalks in an attempt to bring Hubble back from the brink.
The first spacewalk on Hubble, did the dance. When the music starts, what you gonna do? Well, you got a power tool and you unbolt the thing, you undo the connection, zip, zip, stick it in the box. Hang it over there, get the new one out. Slide the new one in. It's fingertips, baby, fingertips.
That's what's so awesome about Hubble. It's almost like plug and play. We installed CoStar. We installed a coprocessor on the computer to give it more memory, added a new magnetometer, and other cats and dogs, as we called it.
It is easy. You've got to make it easy.
Around the world, astronomers anxiously awaited the first pictures from Hubble's new camera. On the 18th of December, 1993, the results came in.
Hey!
Right there!
Oh! Get it!
When an image hit the monitor, the whole room, everyone screamed. It just got it fixed.
Okay. That is better than any deconvolution you've ever seen. Yeah. Those are actually stars.
I think you got it.
Yeah. Yep, sir. Maybe a little premature, but I'll shake your hand.
When the images first came back and I saw them, made me feel proud that I was part of that mission and that we had brought the telescope back to what it was supposed to be. As a matter of fact, my understanding is the images were clearer than what they had ever expected.
To the relief of Ron, NASA, and the entire world, Hubble was finally fixed, and it immediately began to deliver on its original promise, allowing us to see the universe in ways we could previously only dream about. Hubble was only supposed to last 15 years. Instead, it continued to make groundbreaking discoveries for more than 30. But then in 2021, it suddenly shut down. And the team at NASA once again had to fight for Hubble's survival.
So the summer 2021 event was a pretty intense anomaly, probably one of the more dramatic ones that we've had.
Nzinga Toll is the anomaly response manager for Hubble, and it was her job to figure out why Hubble's computer had shut down and ultimately find a way to get it back up and running. But that was far easier said than done. So Nzinga had to think outside the box.
After the first few days, and it wasn't immediately apparent that we could get a path forward to resume science, we knew we'd have to pull in a lot more folks.
With Hubble still showing no signs of life, Nzinga knew she needed some very niche expertise to try and help fix Hubble. So she called upon Hubble's original architects to come back and get stuck in.
When I received the call, I was honored that they would think of me to try and help them resolve this. Anytime you work on a system like this, it's part of you. It's if there's ever a problem with a spacecraft in orbit, everyone jumps in and works on it, even if you're retired. A lot of people were concerned that we would not be able to fix the Hubble. It was very stressful. The last thing I wanted was to have the system that I spent 18 years of my life on to be the cause of the end of the mission. And so I was under a lot of stress.
But undeterred by the challenge, the team set to work to identify what went wrong and get Hubble back online.
The telescope was down for approximately 4 weeks.
I think the first couple of weeks was probably the most frustrating and the most anxiety-producing.
We put together what's known as a fishbone diagram. Everything that could possibly cause the problem was written down, and we eliminated them one by one until we zeroed in on the exact cause. It was amazing how everything came back to me.
On July 15th, Nzinga and her team successfully powered up the backup computer on board Hubble, and over the next few days, the team gradually brought the science instruments back online.
Once we realized that we had solved the problem and the telescope was back up and running, it was quite a relief.
Mainly relief. Mainly a lot of relief.
How did it feel compared to '93?
In my case, it was even better. This was my system that had stopped, that had halted the telescope, and to be able to get it back up and running was very proud. I was very proud when, after the first servicing mission, that we got the telescope up and running, but this was more personal. If another problem comes up, I'd be very proud to work on with this team again to resolve any future issues.
It would be an honor and a privilege for me to be called back to support Hubble at any point in time. I will always be a Hubble hugger.
Early in its history, radioactive elements in its interior would have provided heat that melted the liquid water that's currently ice. And so we think that during the early portions of Ceres' history, it had a global ocean.
In infancy, Ceres was well on its way to becoming a fully fledged world. The water that now lies frozen within its interior was once liquid. Protected beneath a thin layer of ice, ancient Ceres is covered by a deep saltwater ocean. But then, something happens to cut its development short. As the young Jupiter circles the Sun, it clears a path through the gas cloud that envelops the early solar system. But that process causes it to do something alarming. Jupiter begins to spiral inwards, plowing straight through the region of space that would become the asteroid belt.
When the young Jupiter moves through the primordial asteroid belt, things get scattered around, things get gravitationally deflected, and as a consequence of all of this gravitational interaction, more than 99% of the original mass that was there is basically now gone.
The asteroid belt has been disrupted over time by the movement of the giant planets. And this has acted to throw material from the asteroid belt out of the asteroid belt into the outer solar system.
These protoplanetary cores, like Ceres, were never able to graduate to full-fledged planets because there was just not enough material in the orbital neighborhood.
When Jupiter passed through the primordial asteroid belt, it starved Ceres of material, halting its growth. And the dwarf planet was condemned to live out its life as a cold, barren rock. But Ceres isn't the only world in our solar system whose development was cut short. Mars would suffer a similar fate at the hands of Jupiter. After marauding through what would become the asteroid belt, Jupiter enters the region of space where Mars is forming. Continuing its journey, spiraling towards the sun. As Jupiter bulldozes inwards, its immense gravity scatters material in all directions. Some is sent careering into the sun. The sun's outer corona burns at a scorching 1 million degrees, releasing a barrage of charged particles that travel at around 400 kilometers per second. The solar wind. This onslaught would strip away our atmosphere, but for the powerful force that protects us, the Earth's magnetic field.
Solar wind is this stream of charged particles that come streaming out from the sun. And at Earth, which has a powerful magnetic field, when those charged particles begin to get close to Earth, they get diverted around Earth by interactions with that magnetic field.
That protection keeps solar wind and other ionizing radiation off of the surface. So on Earth, where we have this really great magnetic field, we are nice, safe, and sound inside the shell of that, protected from all that radiation.
The magnetic field of Earth effectively forms a protective bubble around the Earth's atmosphere.
And when the sun dips below the horizon, there are times when Earth's protective force field is visible. The aurora is a stunning display of Earth's magnetic field in action. It's best seen at the poles, but across Earth, it's protecting our atmosphere and all life on our planet. This vital protective shield is generated deep within.
The way a magnetic field is generated inside a planet is when you have convective motion in a fluid that is capable of conducting electricity. And in the Earth, that electrically conducting fluid is liquid iron. And the molten portion of the Earth's core is a place where these motions take place, and it can set up a magnetic field.
Just like Earth, Mars once had a molten metallic core, generating a magnetic field around the planet. Auroras danced above Mars's poles, protecting its atmosphere and seas below. But the field didn't last.
In the oldest rocks on Mars, you see evidence of a once powerful magnetic field. You get to the younger rocks, the rocks that are 3 billion, 2 billion, 1 billion years old, no evidence of a magnetic field whatsoever, and there is no intrinsic magnetic field on Mars today.
500 million years after it formed, Mars's magnetic field dies out. The bright auroras above its poles slowly fade away as the shield that protects the planet shuts down for good.
Once it stops, then what happens is all the atmospheric components, things like hydrogen and oxygen that make up water, they get stripped away because you don't have the shield, the magnetic shield anymore, so the high energy particles that come in from the sun and from outer space, they begin to strip away the components that make up water.
Without its magnetic field to protect it, Mars's atmosphere and then water slip away into space. So why did Mars lose its protective shield? What happened deep beneath its surface that stopped Mars from developing like Earth? The answer lies at the beginning of Mars's story, at its very creation. $4.6 billion years ago, when the planets were forming from the dust clouds circling the sun, early differences between Mars and Earth set the young planets on very different paths. Mars forms further from the sun, where crucially, there is less rocky material to build a planet.
Mars is different because it's not just further out, it's actually much smaller. If a planet gets to be too small, it just freezes all the way through.
Mars is just half the diameter of Earth, meaning its core cooled more quickly. And so it lost the heat that powered the dynamo that generated its protective shield. Mars's small size, condemning the planet to die.
The universe is not what you think it is. That's because what you can see is only a tiny fraction of it.
We have no idea what 95% of the universe is. It hardly seems that we understand everything.
Maybe we're just going to have to scratch our heads and start all over again.
It begs the question, why is 95% of the universe missing? For decades, physicists have been trying to find this elusive, undetected part of our universe. And in the beginning, we just had a name for it: dark matter. So what is dark matter?
Sounds exotic, but it doesn't have to be. There's a lot of dark things out there in the universe. Until I shine my light at these bottles, I can't see them. Dark matter could just be ordinary stuff that you can't see.
Now, what we do know about dark matter is that it's matter that doesn't interact with light, so we can't see it. But we know it's there because of its effects due to gravity, because of the way that stars orbit the centers of galaxies. The stars on the edge move a lot faster than they should, so there has to be more matter out there on the outskirts.
Well, there's an alternative idea for what the dark matter could be. And so what we think it is that it's some new kind of fundamental particle. Not neutrons, not protons, not ordinary atomic stuff, but something entirely new. And these particles are everywhere in the universe. They're flying around in our galaxy. They're in this room. Actually, there'd be billions going through you every second. You don't notice, but they're there.
So this invisible matter that dictates how our universe works is known by particle physicists as WIMPs, weakly interacting massive particles. If we can't see them, how do we find them? Part of the problem is that here on Earth, we're searching through a relative swamp of ordinary matter that we can see, which kind of blocks our view of the stuff that we can't see.
If you were to try to build one of these experiments in a laboratory on the surface of the Earth, then your signal would be completely swamped by cosmic rays. They would just ruin your attempt to do the experiment because the count rate from the cosmic rays would be so high that you'd never be able to see the WIMPs.
And that's why scientists are doing something that at first might seem pretty strange. They're going underground and searching in the dark.
After walking a mile underground like this, you have to wonder about the fact that we may be looking in the wrong place. This is the inner vessel of Pico 2L, we call this project, and it goes inside that big recompression chamber. We put a liquid in there, what we call a superheated liquid. It makes it sensitive to radiation. So when particles strike the liquid that goes in there normally, it's now empty, they produce bubbles. Piezoelectric sensors, they're very sophisticated microphones, and through sound we're actually able to differentiate between different types of particles as well.
What sound would dark matter make?
It's actually very soft, it's not the loudest.
But of course there's a chance that looking for dark matter in this way, by essentially listening to it to see if it makes an appearance, might never be possible.
You do your job the best you can and then you hope for the best, but nobody knows if there's WIMPs out there or not. We're trying.
Now, other scientists are searching for this mysterious dark matter by using the world's largest physics experiment at CERN in Switzerland, the Large Hadron Collider. They're not listening out for it, they're attempting to make some from scratch. What they're doing is smashing together known particles at huge speeds to create huge energies in these impacts that might just spew off some particles of dark matter.
When the protons collide, most of the time the particles they produce, nearly always some new particles are created, but they tend to be low mass particles. But sometimes, very rarely, you produce these much more massive particles, and these are the guys that we're really looking for.
So the search for dark matter continues in underground labs and at CERN, and also by observing the night sky. And scientists believe they're getting closer to discovering what it's made of. But will we ever find it?
You have to accept the evidence. And if it turns out that I wasted my life working on the wrong hypothesis, so be it. What I really want to know is, what is the universe made of?
I can really see it as being a particle in nature, and I'm really driven, as we all are driven here, to try and find it.
And if you don't?
We will dust ourselves off and move on.
Whatever they do find will surely change the laws of physics as we know them. With scientists pushing new technologies and the boundaries of our knowledge, what's more, we've now realized that dark matter is only just the start of the story.
So 15 years ago, some astronomers observing distant supernova saw that the distance to those supernovae was larger than they expected. And so the only way that they could understand that was to have a universe that started accelerating 3 billion years ago. And whether that carries on accelerating or not, we don't know. But what we do know is that there has to be another component to the universe, which we call this dark energy.
But you don't know what it is?
No idea. Not at all.
No one knows what it is?
No one. No one. There are more theories than there are theoreticians.
So whilst dark matter might make up 25% of the unknown stuff in the universe, there's this whole other whopping 70% made up of something called dark energy. We know even less about dark energy. It's so weird and so unknown to us that we're actually going to need a whole other video to find out about it.
The question we all want to know is, are we alone? And now we have eyes on the ground. Perseverance is ready to answer that question for us.
Touchdown confirmed. Perseverance safely.
For the last 4 years, I've been recreating the surface of Mars in my lab at the University of Oxford. What I've most been interested in is whether I could recreate lakes and other liquid water environments that might have existed on the surface of Mars about 3.5 billion years ago. Where it gets really interesting is that now NASA has landed a rover, the Perseverance rover, right in a crater that might have once hosted a lake. Although there's no water on the surface of Mars today, there is inescapable evidence that it was once present. When you look at it from space, you'll see certain features that jump out at you as being quite similar to those we have on Earth. You'll see sweeping valleys that look like they were carved from liquid water.
These are actually pebbles that are a few centimeters in diameter. What you can see when you look at the pebble outlines is that they have rounded shapes. So they've been basically rounded during a transport process. And they're too large to have been moved and rounded by wind processes. And so the only way we can actually get this rounding is by water flow.
You'll see gigantic canyons. This one here is the Valles Marineris. And this thing would stretch from Los Angeles to New York. This thing is truly colossal.
And I remember when this image first came up and we were all huddled around a giant screen looking at this. It actually took us a while to really hit home. Oh gosh, actually this is the first evidence from on the ground of water flow on Mars.
We see great big ice caps at the poles, much like we do on Earth as well. We see signs from space that are immediately recognizable as great big channels, enormous floodplains, the largest in the solar system, that would have excoriated their way across plains as large as the continent of North America. We see chemical signatures, we see minerals that have water locked in their structures that could have only formed when that water was freely available. And we also see both of these coming together in the form of certain features that we know from studying them on Earth only form where there's bodies of water. Where Perseverance is sat is a crater called Jezero, and why Jezero crater was selected is that it combines these two key indicators of water in one site. And how deltas form is where you have a river flowing across the surface of a planet, and in its water it's containing all kinds of churned up sediments. And then as soon as that river reaches an open body of water, like a lake or an ocean, it dumps all of that sediment load. Why the Perseverance mission is so exciting to me is that for the past 4 years, it was those carbonates that are found in its delta that I was trying to recreate in my lab. Perseverance has been in the making for a very long time, and it's a roving scientific suite of instruments. It's a moving laboratory, and it's absolutely incredible the things it can do. So to finally get to hear the sounds of grains of sand being turned over, and the sounds of that very thin atmosphere being blustered around in this crater, it's absolutely incredible. The first times I saw the pictures from the surface, it was like being in Star Wars and learning about whole new places. I couldn't believe it, and here, 5-6 years later, I am with my PhD on the surface of Mars. I feel very, very fortunate.
Altimeter data confirm that Ingenuity has performed its first flight of a powered aircraft to another planet.
What's incredible about the little Ingenuity craft is that this is the first time anything has been airborne on another planet at all, not just Mars.
So the image we're looking at on the screen is the image from our onboard navigation camera showing us hovering above the surface of Mars. How incredible!
The idea is that it might be able to scout ahead to places of interest for future astronauts and look for any hazards. Perseverance has 4 main scientific goals. First is to search for habitable conditions. The second is it's interested in searching for biosignatures. The third mission goal is to harvest and then cache together samples of interest to return to Earth. The absolute dream is to one day have a sample of Martian soil returned from Jezero crater from those carbonates that you can see from orbit, and to compare that to the kinds of crystals that I was forming in my lab, and just see how similar are they, what do they look like. And the final goal of the Perseverance mission is to prepare for humans to come and live there one day. People who are fit, people who are top in their fields, people who are experts, people who have a spirit of adventure. But I would say most critically, you need people who have the right temperament.
Think about a mission to Mars. What is it? Is it outdoor stuff or is it confinement? And then I see somebody that says, I have a stamp collection, I do a lot of reading, I enjoy watching movies, and I'm thinking, that might be good for confinement.
Artemis is a key step in getting humans to Mars. Right now, launching humans from Earth is extremely expensive because we're just so heavy getting off this gigantic rock. Instead, if we can have a base set up on the moon, we can have supplies ready to go from there, manufactured on the moon, that can then be launched straight to Mars. And so this makes it cheaper and easier to be launching things not just to Mars, but perhaps around the solar system as well. Once you've got to Mars, there are a whole host of problems that you wouldn't even think about based on life on Earth.
So you need something to protect you from essentially exploding, or at least having your skin all stretched out and the blood boiling and getting the bends, things like that. The way spacesuits are designed now, they're mostly pressurized spacecraft. Essentially, they're almost like a mini spaceship.
Things like, how do you maintain water? How do you recycle your water supply? How do you recycle waste?
Here we are at the throne. Number 2, right here. It's pretty small, so you have to have pretty good aim.
How do you keep making the best of everything you've got without throwing things away? And they're all problems that we're going to have to overcome if we're ever going to be a spacefaring interplanetary species. I've had a very long time to think about whether I would go to Mars, and so I'm not being flippant when I say yes, absolutely. Would absolutely love to go. It would be the most fabulous adventure. There'd be so much to do and explore, and so many questions, endless questions. So yes, absolutely.
Big Bang was not the moment of creation.
It was actually this. The cosmic dawn, the moment that the very first star in the universe was formed and started forging the materials that we need to make you, me, and everything around us. This is your origin story.
Several million years after the Big Bang, the universe was dark and boring, filled with cold hydrogen atoms floating through space. All the things we treasure did not exist.
The Big Bang created space and time and all of the essential ingredients, but it didn't create anything that was recognizable as our present-day universe. Instead, it left us with one of the most boring periods in the universe's history, the cosmic Dark Ages.
If you go back to this time of the Dark Ages, the universe looked completely different. If we had a human observer translated back in time, we would see a completely dark, boring, featureless universe. An utterly alien place, it would appear to us. It was a universe without any light. There were no stars, no galaxies.
Now, the transformation of our universe into one that we would recognize didn't start until the first stars were born.
The cosmic dawn would have been spectacular.
There was this magical, if you like, metaphysical moment.
It was the starting point that led to the appearance of life.
The moment of first light.
Let there be light.
The first stars are fundamental to how the universe evolved.
New galaxies were forming out of darkness. This age of enlightenment was a very dynamic period of time.
What we found is that in the early universe, stars are much more massive, maybe even 100 times more massive than the Sun. That has dramatic consequences because massive stars have a very different life, a much more violent life than the kind of low-mass star that the Sun is. They would be 20 times hotter, shining ultraviolet blue, 10 million times more luminous than the Sun.
They're gonna live for a very short time, only a few million years. That's really nothing. We often say they're like the rock stars in the universe. They live fast and die young.
Stars were appearing and disappearing.
It's like fireworks. It's very dynamic.
It grew up exponentially, Very quickly, within tens of millions of years, there were plenty of stars filling up the universe. The cosmic dawn is the beginning of complexity in the universe that led to our existence.
So stars are essentially giant furnaces, right? They take the simplest element, hydrogen, and they transform it into the heavier elements needed for life. This is why stars are so important. They create the sugar, spice, and all things nice needed to make you, me, and the Powerpuff Girls.
For the first time, new elements are being made. They take hydrogen, turn it into helium. Helium gets combined to make carbon, and we go to oxygen and silicon.
The rocks that we see have been formed inside a stellar interior and then thrown back out into the universe. The gold and the silver and the rings on my finger, they've all been made in a supernova. There's no other place in the universe that you can create elements like that.
So it might sound like an internet meme, but it's true. We literally all are made of stardust. We have astrophysicist Margaret Burbidge to thank for that. She actually managed to figure out what was going on inside stars. So far, so good, right? We've got this epic theory of creation that took billions of years just to get the ingredients for you and me. But how do we actually go about proving that that's what happened? So scientists are on the hunt for eyewitnesses, stars that could have been there at that first moment, that cosmic dawn. Luckily, astronomers on the search for ancient stars know what to look for. We know that they are much bluer than the stars of today. That's because ancient stars are made out of pure hydrogen, so they burn much more efficiently and therefore much hotter, which means they're blue. Think about like the flame on a hob or a Bunsen burner, which burns blue, compared to the flame of a candle or the dying embers of a fire, which burns orangey red. In 2013, Stephen Keller and his team found that needle in a haystack, an ancient star in our own Milky Way galaxy that provides valuable clues about what happened at the cosmic dawn.
At first we thought we must have done something wrong here, but we confirmed it the next night, and that's when things really got exciting. It's been around for 13.6 billion years. It's a very pristine star. It formed very early on in the history of the universe. In fact, what we're able to do with this star is, for the first time, say that there was only one star that preceded it.
So this is the purest star that we've ever found, making it the oldest star that we know of. But it's still only a second-generation star, not a first-generation star, the first to form in our universe. We need to find one of those. This is why astronomers are excited for the launch of the James Webb Space Telescope later this year, because it might just have a chance of spotting some of these first stars being born. So there was the Big Bang, and then 100 million years of nothing, and then there was the big switch, when the universe finally turned on the lights. The cosmic dawn. This finally gives us a scientific answer to one of the biggest questions that humanity has ever asked, one we've been searching for answers to for millennia. Where did all this come from? Well, it turns out that the device you're watching this on, the chair you're sat on, and even you yourself, all of the stuff that makes all that comes from stars.
We are all curious where we came from. If one opens the first chapter of Genesis in the Bible, the Old Testament, one finds a version of this story, how the universe started and how we humans came to live in it. Some bits of this story are right. There was a beginning in time. Light came into existence from darkness. Life was created. We are now at a special time that allows us to explore this question scientifically. We are able to peer deep into space and see those very early sources of light that tell us how we came into existence. And of course, with modern technology, we are hoping to get the story much more accurate.
I'm NASA astronaut Jessica Meir. I may be one of the first people to return to the moon. The Artemis mission has this stated goal of sending the first woman and the first person of color to the surface of the moon. It will have been over 50 years since humans have set foot there. We aren't just going to go there once and then come back, or go there a few times like in the Apollo missions and then come back. We're going to keep this presence going with a gateway program that will be an outpost in orbit around the moon. Think of it kind of like a little mini space station with subsequent missions of landings on the moon, and then eventually using all of that time and knowledge in those lunar missions as a springboard to go even further and go to Mars. My mom tells me I first started saying I wanted to be an astronaut when I was 5 years old, so it actually was quite difficult to believe when it came true in 2013 when the phone rang and I was given the option to come here to NASA to be an astronaut. It's almost felt surreal.
Copy, Jessica's egressing, 10 seconds to a 20-second handover.
Coming out of the hatch for your first spacewalk is a moment that I don't think anyone ever forgets. My first spacewalk happened to be only a few weeks after I arrived on the space station. So at that point, I was still learning how to move and navigate myself around on the space station. That day, I was with my colleague and friend, Christina Cook. She was in the same class of astronauts as me, so we really are like astronaut siblings. She's like my space sister. We were ready to go out of the hatch that day for the first all-female spacewalk. Of course, there had been other women that had done spacewalks before us. We were the 14th and 15th women to do so, but this was the first time that two women together were going to embark on a spacewalk. So there I am, and I'm looking down at my feet, dangling below the hatch, and then there is nothing else between this Earth spinning below and my feet. And that was just the most profound moment. I was just in awe and so excited. Just us up there. We're floating the whole time, going around our planet every 90 minutes. It was still, even though I was living it, even though I understood the science behind why I was there, it was still difficult to believe that it was actually happening. So it was really only after the spacewalk ended that I started thinking more about what it meant. And it was interesting because in the beginning I thought, why does it matter? Why is there so much attention being drawn to this first all-female spacewalk? It just happens to be the fact that right now there are two women going out the door. We're just as qualified as everybody else up here, and so it's just a matter of time that this would happen. But then when I started thinking about it differently, so many people tuned in to watch that spacewalk, and so many people started giving us this feedback about how inspiring it was for them and how much it meant for them. And that really took me a little bit by surprise. And I also started thinking more about the generations that came before us. So Christina and I, both of us, when we look at this now, we don't think about it as our personal achievement. We had that opportunity because of the generations of women and other minorities that had worked so hard, that had truly pushed the envelope and broken those glass ceilings to allow us to be where we were. So now, when we look toward the future and we look at the Artemis program, this administration has set forth the goal that we will be sending the first woman and the first person of color to the surface of the moon. Of course, I would be absolutely thrilled to be that person, to be one of these first people returning to the moon. And to me, it would represent so much. I know somebody asked me once what I would say, what would be those first words, like we have those famous first words from the Apollo mission. And that is something I would have to put a lot of thought into. I think to me it would be a little bit like how I described that first all-female spacewalk. It wouldn't be about my achievement. It would be about the achievement of everybody on this NASA team that got there. And it wouldn't even only be limited to that. Really, that next person that goes to the moon is a representative of all of humanity. So a lot of people ask us, why haven't we been back to the moon? If we did this 50 years ago, why is it so difficult? Why haven't we been doing it? There's nothing easy about going to the moon. What we accomplished in the 60s was extraordinary. We are due to go back to the moon for so many reasons. The first is simply for exploration. It is an inherent characteristic inside us as humans to explore, to want to look around the corner, to go further, to ask those questions and just quench that curiosity that we have. Secondly, though, and equally as important, is for scientific reasons. If we look back at the Apollo missions, we learned so much about our solar system, about the formation of our planet and of the moon, and I know that that will be true as well for the Artemis missions. For example, we'll be targeting the South Pole because at that area, we know that there is much more frozen water. So by going to that spot, we can study and understand that water, that ice, that frozen water will help us understand more about the moon, about our solar system, and it will also be a resource. We can use oxygen in the soil, we can use that frozen water in the surface, we can use that to make fuel, to make resources for further exploration. So that would be that next step. Take what we learn in the proving ground around the moon and now use that to get to Mars, where we need to be autonomous. We need to think about things like sustainable food systems. We won't even be able to necessarily carry all the food and water that we need up there. So maybe we want to bring some things that we can grow. Everything that we learn in these early Artemis missions to the moon will apply then on to Mars. Fairly soon, we will be launching that Artemis 1 test mission, and that mission will be about 3 weeks. It will go all the way out to the moon and beyond it, and we will test out all of those systems of the Orion spacecraft and that launch system. The next mission, the Artemis 2 mission, would have crew members on it. So that will be the first mission that has astronauts going out to the moon. They won't yet land on the surface of the moon, but they will go out again further than the moon. They will be in orbit around the moon before they come back here. So that will be another vital step in making sure we have everything ready and we're prepared for those later missions, which will then land on the surface of the moon. We'll also have the Gateway, which will be in orbit around the moon. So think of it kind of like a little mini space station. Instead of being around the Earth, though, it'll be there proximal to the moon. And then we can use that to go back and forth. We can keep people on board the Gateway, and then we can have regular excursions down to the surface of the moon. We can use that as a test bed for other hardware and technology and experiments. And then we can eventually use that as a stepping stone to getting to Mars. To me, the moon represents this spirit of exploration that I think has driven humans from the beginning of evolution of our species, and also me personally. The stars, the Milky Way, the moon were so bright in our view, and I think that's something that really shaped part of my childhood, letting that natural scientific curiosity, that spirit of exploration, extend not only from what was in front of me on the ground, but also to what was lying up there above. And of course, the moon is this incredibly prominent object and something that I think we're all drawn to. It makes me so optimistic now to know that it is a national priority again. We have laid out this foundation to get back to the moon, so we will return.
You've waited years for this! I waited years!
This was almost the perfect day. Almost.
Rosetta was and is a unique space mission.
It's a travel not just in space, it's also a travel back in time to the very early days of the solar system.
This is the story of the epic, ambitious mission to land a spacecraft on a comet hurtling through space. Nothing like it had ever been attempted before or since.
Rosetta completely transformed our view of comets.
It was a mission 25 years in the making that all came down to a few frantic hours.
Philae was not anchored.
It bounced. We don't know where it is.
But let's go back a bit to 2004. The Rosetta spacecraft, with its little Philae lander tucked away inside, is about to launch.
3, 2, unité. Top, allumage EAP, décollage.
Well, the actual launch took place on 2nd of March in 2004.
The first part of the mission was just to catch up with the mysterious comet, known as 67P. That took 10 years, during which time everything on board Rosetta was powered down, only to be woken up as it neared the comet.
It was quite a nervous time when Rosetta was coming out of hibernation.
Because if it didn't wake up, that was curtains, really.
€1 billion of kit out in space, and if it didn't call home at the expected time, there was very little that could be done about it.
And then it got this signal, wake up Rosetta, and it's just like, hasn't woken up. All right, send the signal again. Switch it off and switch it on again. Ta-da! It's woken up, which was just so much of a relief.
Hurdle 1 out the way.
When Rosetta woke up, that was really the point where everybody got excited again. We had no idea how the comet would look like.
We don't know what shape it is. It's probably spherical-ish.
We didn't immediately see the high quality images. We saw better and better ones the closer and closer Rosetta came.
Then, wow, what shape is that?
The shape is not potato-shaped as we expected, not roundish. It's
The comet has this kind of rubber duck shape.
It's like one of those yellow plastic ducks.
And that made hurdle 2 that extra bit harder, landing Philae safely on top of it.
There was no area on this comet which is nice and smooth as we have hoped for. The terrain was rough everywhere. So there was a risk, but that also made it fascinating and interesting.
Philae was equipped with little harpoons to fire off to help it cling to the comet once it made contact. And the landing site had to be meticulously chosen to allow Philae to recharge its solar batteries in the glow of the sun. The stakes were huge. This was a lifetime's work for most of the scientists on the Rosetta mission. The team already knew there may be a problem with the thrusters that were supposed to slow down Philae's approach, but the time had come to deploy Philae. And on the 12th of November 2014, off it went.
One could see the Philae lander as it moves away from the main spacecraft, getting smaller and smaller with the landing gear successfully deployed. I found this already very emotional to see the baby go after 10 years attached to the spacecraft. You now see it in freedom on its way the last 22 kilometers to the surface of the comet. And then Philae was free falling for almost exactly 7 hours to the surface of the comet.
Everybody was, jittery and just waiting and waiting and waiting for the signal to say it had landed.
And then
I just went absolutely, hey, it's landed, I'm so excited, it's landed. It was just the tension that had wound up and the release of that tension and the relief.
We've waited years for this.
I waited years. I'm just so excited. I'm gonna cry. I'm sorry. It's fantastic.
And of course, everywhere in the world, in the control rooms, in the scientific teams, people started to open the champagne and started to celebrate.
It landed. It was fantastic. It was wonderful. Everybody was really, really, really happy.
In the control room, we thought, yeah, great, we are landed. We have the touchdown signal.
But the mood in the control room was suddenly very different. Something wasn't quite right.
Within a few minutes, we realized that although we have landed and although we still got radio contact, which was positive, we did not anchor and the lander was moving again.
And then the principal investigators came out of their little cocoon and Ian came up to me and he gave me a big hug and I gave him a big hug and I said, oh, it's fantastic, isn't it? It's really great, you must be so proud and pleased. And he said, no, it has gone wrong. It bounced. We don't know where it is. I said, what do you mean? He said, well, it hasn't been announced yet, but it will be announced in a minute that actually Philae did land, but the harpoon didn't anchor it and the little crampons on the legs couldn't get a grip, and so it's bounced.
And we had no idea what's going on, where we would jump and how we would land and when we would land.
Oh dear.
Philae had crashed off the face of the comet and bounced about 1 kilometre back into space, any further, and it risked escaping the comet's weak gravitational pull and drifting off into space forever. Anxiously, they waited.
We had no idea whether this would be a successful mission or would be just a touch and we would never again hear from the landers.
And then the news came in.
So we did land somewhere and we still had radio contact. We still received signals, and this was the moment of great relief, because that was the moment where we knew we are at the surface and we can still communicate with the lander.
But the good news didn't last long. It had landed in the shade. Not great for something reliant on solar power. This meant they had less than 72 hours of battery time to undertake months' worth of scientific collection. The clock was ticking.
So it's one of those things, it's like, okay, let's just throw away 10 years worth of calculations and let's just redo them all over the space of 5 hours, which is what they did.
We also optimized the sequence in a way to get the maximum science out of the energy available.
Once they knew they'd only got 70 hours and it was just going to seep away, it's like, it wasn't if you turned all the instruments off, the battery would stay at that particular level. No, because it was so cold, it was having to maintain, it was having to keep heaters on as well, you know, to make sure that the instruments kept working. So you just knew you'd got 70 hours full stop, all right? So you worked for 70 hours. You just did it. You just barreled through. Get as much data as we can.
And amazingly, almost all of the instruments on Philae had survived the impact. It was go time.
We were very lucky. I mean, we ended up in an orientation that the antennae were pointing, well, upward, so to say, that we could establish the radio link with the main spacecraft. And again, we were also lucky because we could switch on the instruments. We could do fantastic science from the surface of the comet.
About 80% of the science goals of the Philae lander were achieved. So it was an absolute fantastic success. You know, the fact it crash landed, got around that. It was an amazing success.
This was, of course, a bit sad to see the voltage of the battery drop and knowing that Philae will go into a hibernation.
And eventually, that's what happened. But even in those few hours, Philae had unveiled a world full of surprises. Of dust and debris, gases erupted from deep within the comet. Even the crash landing threw up interesting discoveries.
Even by analyzing the bounce itself, we got information on what's the surface made of. And it was a bit surprising that the surface was rather hard.
But perhaps most exciting of all was what this comet was able to teach us about us.
The Rosetta mission had as one of its goals to understand the building blocks of life.
Because Comet 67P was rich in organic compounds like phosphorus, carbon, oxygen, nitrogen, and the amino acid glycine, all essential for the origins of life, and offering tantalizing clues as to how these compounds may have arrived on Earth in the first place.
So the original building blocks of life came from comets.
While Philae had gone into eternal hibernation, the mothership Rosetta continued to fly around the comet, collecting data for 2 more years. But then, Rosetta's time had to come. In a last-ditch effort to get as much out of the mission as possible, the team decided to crash land Rosetta into the comet, collecting data along the way and allowing the scientists to get one last look at their old friend Philae.
Took this sort of shallow dive onto the surface of the comet and then sort of crash landed, and its camera was going the whole time. So we saw these last pictures of the surface rushing up to greet Rosetta. And then the signal died, and you got this little sort of oscilloscope thing with nothing on it. Just like, you know, like somebody when they die and you see the signal die on the heart thing. And it was just like, it was It was so devastating. People were in tears. I cried. And it's just hell's teeth. It's a robot, you know. But it's been part of your life for so long and so important. So that was it. That was the end of the Rosetta mission.
There is still many publications done using the data from Rosetta. That's still the most relevant and best scientific information we have from a comet.
Rosetta completely transformed our view of comets.
To some extent, what we know about the evolution of the solar system and what we believe about the formation of life, all of this is triggered by Rosetta, and this is not often in lifetime you get a chance to get involved in such a project.
Like Jess Barnes, geologist Katie Joy is fascinated by the far side mystery.
Because people hadn't seen the far side of the moon, we just made the assumption that the far side was the same as the near side. So Luna 3 turned our ideas on its head, and those ideas are still being turned on our head.
Katie is one of NASA's lead investigators, studying the precious Apollo samples to better understand the moon's mysterious past.
Because the moon's surface is very old, it can tell us a lot about history of the solar system's past. It can tell us about Mars, Mercury, Venus, and the Earth. Every time there's new technology, we can ask these rocks new questions, and that's why they're sort of the gift that keeps on giving, because they're always going to be available for us to look at with new ideas.
The Apollo samples continue to teach us about the moon, the Earth, and the rest of the solar system. But when it comes to solving the far side mystery, there's a problem.
With the lunar missions that have been to the surface and collected samples, we've only visited a very geologically restricted area on the near side of the moon. So in order to fully understand the moon and the far side composition, we really need to go back and collect samples from a more diverse region.
And with NASA's Artemis mission, aiming to return humans to the lunar surface in the coming years, Jess is preparing for a new batch of evidence.
We want to preserve that DNA, fingerprints, rocks as precisely as possible so that we don't lose any of that evidence. So before we go back to the moon, we really need to understand what's the best way to curate and keep samples safe and preserve them for future generations.
To get ready for these upcoming missions, NASA is releasing some crucial, untouched evidence from its vaults.
After Apollo 17, people soon realized that it would be beneficial to future generations to lock some of the Apollo samples away in special storage for 50 years. And now we're at the point in time when NASA has decided things have improved so much that we're now at a position to open those samples, use new technologies on them to answer past and new questions.
Now, armed with techniques impossible 50 years ago, Jess is one of the handful of people chosen by NASA to analyze these precious samples.
One of the things that we've been doing is using a particle accelerator to measure the oxidation state of sulfur in our samples. We're really looking at these samples forensically, and this is a really new technique that's been applied to lunar samples only in the last few years. So yeah, bring it up a little bit and we can do a slow scan.
This tool allows Jess to piece together the sample's history and establish how new evidence might be better preserved in the future.
We find that samples that were prepared 50 years ago contain a lot more sulfur than we see in samples that were actually stored frozen for 50 years. We're not quite sure why that is, but this is one of the things that we want to find out. Do we need to do something differently for samples coming back from the moon in the future?
It's a problem that must be addressed before we return for more evidence. Something Jess knows is critical if we're ever to finally solve the mystery of the moon's far side. In 1996, scientists announced they'd found evidence of possible Martian life. But Mars is a frozen desert planet, Its surface is completely uninhabitable. So could these strange shapes really be ancient alien fossils?
Release and liftoff.
And why do scientists think they might be able to find more of them?
I've always loved space. There's all kinds of things moving around, and we have no idea what's out there.
Planetary scientist Nina Lanza knows it can be difficult to interpret images from space.
This is Percival Lowell, who was an astronomer in the 1880s who was obsessed with Mars. He made many observations of the surface of Mars using telescopes on the ground on Earth.
Lowell's maps of Mars led to an idea that has enthralled us ever since.
What he thought he saw were these canal features. He thought he could see signs of a civilization on the surface of Mars. And these ideas had a huge impact, not just on science fiction, but also actual science.
So in 1964, when NASA's pioneering Mariner 4 probe reached the Red Planet, the public eagerly awaited their first look at the alien world.
Mariner 4 was the very first time we had close-up images of Mars from a spacecraft. People, when they first saw them, were incredibly disappointed because they looked nothing like the Mars of our imagination. There were no alien civilizations, there was no water, there were just a bunch of craters, and it really looked like the moon.
But just 7 years later, Mariner 9 made scientists think again. Its more powerful camera revealed something remarkable etched on the Martian surface.
This is an image from Mariner 9, and it's a really important image because it was the first time scientists saw evidence that there might be something more on the surface than just craters. This is a very sinuous channel that looks like it was carved by flowing water.
Each mission that followed has unearthed more evidence that Mars was not always a dry, frozen planet.
The Viking orbiters sent back some incredibly beautiful images, things like these flowing channels and teardrop islands, both of which suggest that water was once abundant on the surface and flowing, making these features. Mars Global Surveyor sent back this one, which shows a feature that looks like a beautiful river delta. The twin rovers Spirit and Opportunity found dramatic evidence. These are hematite spheres, and they form in water. This is a vein of a mineral called gypsum. So gypsum is a mineral that not only forms in water, but actually contains water in its structure.
It's now known that in the first 1 or 2 billion years of its life, Mars was much more like Earth. It had a thick atmosphere and was covered in rivers, lakes, and seas.
There is overwhelming evidence, just looking at the surface, that there was a lot of liquid water on Mars's surface in the past.
However, this discovery, while extraordinary, did not prove Mars also had life.
Life needs water, but that's only one thing that it needs. It also needs certain chemical ingredients and also environmental conditions before it can actually develop and thrive.
The northern lights on Jupiter are the most spectacular in our solar system. They're stunning, and they're bigger than our entire planet. They produce incredibly powerful flares that reach terawatts of power. That's more energy than you'd need to briefly supply all of human civilization. What causes them? Why do they seem to pulse like clockwork? To truly unlock Jupiter's mysteries, we needed a way to get closer to it than ever before.
Jupiter is the most extreme environment NASA's ever visited. To send a spacecraft there is a little bit insane. We had to, build an armored tank to go there.
Juno arrived in Jupiter's orbit in 2016. As it got closer, the auroras on Jupiter became so dramatic and active that astronomers said it was like Jupiter was putting on a fireworks display for Juno's arrival. which seems apt given the sheer scale of the spacecraft.
Behind me is the Juno spacecraft, basically life-size. It's an enormous spacecraft, close to 70 feet in diameter as it spins around and cartwheels through space. This is one of the largest spacecraft ever made.
Juno showed us more than we'd ever seen of Jupiter's auroras as they rippled over the planet's poles. The northern lights on Earth are caused by solar winds entering our atmosphere and interacting with the planet's magnetic field. Jupiter's magnetic field, also known as the magnetosphere, is 20,000 times stronger than the one here on Earth.
It extends all the way back to Saturn and perhaps further. And it's the biggest structure in the solar system next to the Sun's magnetosphere.
That's one of the reasons Jupiter's auroras are so huge. These gigantic magnetic tentacles capture particles from across the solar system, thrusting them towards the planet's poles, creating this epic light show that never dies. But this is only part of the story. As well as photographing Jupiter's dazzling displays, Juno also began mapping Jupiter's core. And that's when things got interesting. Jupiter is a gas giant. It is full of loads of gas, especially hydrogen and helium. And when hydrogen is under extreme pressure, it acts in a really weird way. It becomes liquid metal. Liquid metal! Like at the core of Jupiter is an ocean of liquid metallic hydrogen. And using some of Juno's findings, physicists in California tried to recreate this extraordinary phenomenon, bubbling away deep inside Jupiter's core.
So basically we are creating a little planet interior inside our laboratory.
Marius Mio and his team at the National Ignition Facility conducted a pretty crazy experiment. They fired lasers at a tiny target, which imitates the core of Jupiter. The lasers simulate the unfathomable pressures going on inside.
So this is the target that we put inside this target chamber. We fill a little portion inside this cone here with liquid hydrogen, about 20 millionths of a gram, and then we shine 80 laser beams from the top and 80 laser beams from the bottom. So the power that we put in the lasers when we shine the laser onto the target is about 500 times the power that is used for the entire United States at a given moment.
5, 4, 3, 2, 1, shot.
Through the laser blast, the team observed this surreal change that takes place in the core of Jupiter.
At this time, the pressure got so high that the light is now reflecting off the shiny surface of the hydrogen. Hydrogen transforms from being transparent to opaque and then becomes a metal, like a shiny metal. If we were to go deep inside Jupiter, we would see a deep ocean of fluid, shiny metal.
And just like that, the planet completely messed with what's possible with the elements. It throws out the rulebook. On Jupiter, this metallic hydrogen makes up to potentially 50% of the planet's mass. And it's this huge liquid metal ocean that accounts for Jupiter's gigantic magnetic field. But that's not all. It also causes charged particles to leak out at its extremities. And it's this that causes the breathtaking auroras that outshine all the others in the solar system. So Jupiter's core is the main source of the auroras, but its moons also wanted to get in on the act, particularly one of the strangest moons in the solar system, Io. This moon is the most volcanically active in the solar system. Its spectacular volcanoes spew plumes up to 300 miles into the atmosphere, adding extra fuel to Jupiter's light show.
So we see Jupiter in the middle, but around Jupiter we see the moons, Io, Europa, Ganymede, Callisto. The gases that come from Io become trapped in the magnetic field, and they become accelerated to very high energies.
These trapped charged particles get dragged towards Jupiter's poles by its all-encompassing magnetosphere.
Energetic charged particles come in, bombard the atmosphere, make it glow. And then we're seeing this glow in the atmosphere of Jupiter.
So the combination of the gigantic magnetosphere, its supercharged liquid metal core, and unique moons create these breathtaking aurorae. But astrophysicists were still puzzled by one thing. Why do these aurorae light up and flash in semi-regular patterns, pulsing in this extremely bizarre way? It took a team at UCL to crack the case. In the time they watched the auroras, they found that they pulsed every 27 minutes. By closely analysing the data sent back from Juno and the European Space Agency telescope XMM Newton, they came to the conclusion that periodic vibrations crashed across the magnetosphere, causing waves of plasma to send heavy ion particles surfing across the magnetic field toward Jupiter. But the mystery isn't over. Just what causes these vibrations? What determines the pattern of these pulses? And why does Jupiter randomly decide on these rhythmic, regular intervals? This is just the beginning of our learning about Jupiter's auroras. And that's just the start of a wider search. There are more like them across the galaxy, waiting to be explored.
Nearly everything we've sent into space is still there circling our planet. Huge amounts of abandoned old machinery just littering space. It really is a terrifying thought.
When you're going 17,000 miles an hour, it does not take a big piece of debris to ruin your day.
The energy would be more like a 50 caliber Browning machine gun sniper round.
Experts are now beginning to ask, have we trashed space forever? Over the last several years, orbits around Earth have become littered with satellites and old pieces of machinery. So how much junk is in space?
Space junk is all the stuff that we've launched into orbit that no longer serves a useful purpose. So it's satellites, it's rocket bodies, it's old gloves, basically litter that we've left in space.
Now, this isn't a trivial issue because as we enter into a period of more rapid space expansion, from space tourism to companies putting more smaller satellites into space, it's now estimated that the number of pieces of space junk up there is over 130 million pieces that are orbiting the Earth, and that number is only growing. So space is being littered with these dangerous, uncrewed pieces of machinery flying through space at breakneck speeds. It's a lethal accident waiting to happen. So what happens when junk collides?
Copy, Al. You're on your way to the station. Houston, big loop.
Bag, and I'm going around.
In 2009, NASA actually had to order an emergency evacuation of the International Space Station when they discovered a piece of space junk about the same size as a CD traveling towards them at 8 kilometers a second.
We got a call that we were having a red conjunction, and we're looking around, what the heck is a red conjunction, because we hadn't really trained for it. It was a little bit chaotic because this was the first time we had had one of these.
Copy, Al. You're on your way to the station. Houston, big loop. Bag, and I'm going around ESG2.
It's either going to hit or it's not going to hit. And so worrying about it doesn't help you. All you have to do is just prepare everything that you need to prepare so that if it hits, then you're in the best possible configuration.
Now, thankfully, the ISS wasn't hit that time, but this is a genuine concern for NASA, ESA, and other space agencies, because if it was hit, the damage would be catastrophic.
It gets hit by something relatively small, penetrates, but because the pressure inside it just forces the modules to open up, just like a balloon bursting. And that happens extremely quickly, and with no chance that an astronaut in that module could ever get out.
In fact, you can recreate these kind of collisions in a lab, and it really reveals how dangerous they really are.
You see your screen flash up, and it's over. All that work is turned into this. So this piece of modern art here, you can see it's all splayed out. Now that's about 250 milligrams. So that's a little bit bigger than heavier than a ibuprofen pill. And
The energy that would have on orbit at, say, 14 kilometers per second would be, well, the momentum would be about the same as a hot-loaded 357 Magnum. So that's a lot of momentum. And the energy would be more like a 50 caliber Browning machine gun sniper round.
A single one of these collisions can create thousands of these tiny lethal fragments that act like space bullets that ripple out into space, causing unimaginable damage as they go. In fact, some forecasts suggest that a major collision like this could happen once every 5 years.
We see thousands and thousands of near misses every single day as a result of all the junk that we put up there. You end up in the situation where, you know, it's basically a lottery in terms of whether or not your satellite is going to be hit.
And this wouldn't just cause issues up in space. With so much of our modern world dependent on satellites for things like navigation and the internet, communications, weather forecasting, it would cause absolute havoc down here on Earth as well. Now, with more and more of these objects being blasted into space every single year, it's becoming a serious threat to modern life. So what can we do about it, and how will we solve this problem? Step one is actually tracking all of this space junk, and that's something that the US Air Force has been doing for decades.
Pre-pass SVN-26.
No time-critical commanding, no satellite conjunctions, good on step 6.
They've been cataloguing space junk since the early 80s. They started with 6,000 and have grown to 10,000 over the next 2 decades. And since 2009, the amount of trackable space junk has gone up by 20% to over 25,000 pieces. But the problem is, the only space junk that's trackable is stuff larger than a cricket ball, and it misses those tiny, tiny fragments that can be incredibly lethal. So space agencies across the globe are working round the clock to come up with solutions to remove this space junk. One option? To use a space harpoon.
This system will capture those items of debris, tow them out of the orbits where they might collide with active satellites, and allow them to burn up safely in the atmosphere. So the idea is to have a system which takes them away from where they cause a problem and basically destroy them safely.
It's a great idea, but the thing is, it's a bit of a slow tactic because you have to remove everything piece by piece, and the problem is we're putting even more space junk up there just to do this. Now, other plans include capturing them in a net, or sticking a magnetic thruster onto them, or even using solar radiation to sail them off into the sunset. It just shows, though, with so many of these ideas being developed, how dangerous of an issue this actually is. And if our quest to remove this junk fails, and with the increase in objects littering space every single day, the question is, have we ruined space forever?
I want my kids and my kids' kids to be able to explore space. And if we ruin the environment, we can't do that. And that would be tragic, because my passion for space came when I was 10 years old and I watched Apollo 11 and I watched Neil Armstrong walk on the moon. And that magic that created that feeling in me that said, I want to do space. I want my kids and my kids' kids to have that opportunity. And if the space environment is ruined, that'll never happen.
So just like we've seen laws come in to protect our environment here on Earth, we could also see laws come in to help protect space and the environment around Earth, with the hope of preserving the wonder and the beauty of the night sky for generations to come. Now, aliens contacting us might seem like science fiction, but now new mysterious signals from outer space are intriguing scientists around the world.
This signal was so bright that it was completely unlike anything we'd ever seen before.
It's not crazy to think that radio bursts could be created on another planet.
What causes them is one of the biggest mysteries in physics. So are these signals from aliens? Now, linking strange signals from space with aliens sounds a bit like something cooked up by conspiracy theorists. So is this real science? Yes, this is real science. It's the job of an astrobiologist to figure out where in the universe is habitable and if possibly intelligent life could have developed there and then contacted us. In fact, in 1961, pioneering astronomer Frank Drake organised a now infamous secret meeting to try and figure out how many civilizations like this exist outside of our own.
So we start out with the rate of star formation. Multiply that by the fraction of stars which actually have planets, habitable planets in each system, the fraction on which life develops, the fraction by which intelligence appears, by the fraction of those which actually give a detectable technology. This rate times the average time that these civilizations remain detectable. N equals about 10,000 detectable civilizations at present in our galaxy, the Milky Way.
Calling themselves the Order of the Dolphin, this group of award-winning scientists set out on the hunt for this huge number of civilizations that they thought could be out there.
Oh, I believe very strongly that they are out there. We can be very, very wrong, and yet there will be many, many detectable civilizations.
From secret government agencies to Nobel Prize winning scientists, the search was on for weird, unexplained signals. First, there was the WOW signal in 1977, detected by the Big Ear radio telescope in Ohio.
The signal was strong, about 72 seconds, but more importantly, it was detected in something known as the hydrogen line. That was significant because at the time, astronomers thought that if extraterrestrials did exist, they would use that frequency. The astronomer Jerry Emmon was so excited that he actually wrote the term WOW on the printout.
But very quickly it was dismissed by astronomers as actually coming from a comet. Then in 2007 came a detection of what would become the biggest mystery in physics, something that could have been a game changer in the search for aliens.
My student showed me this signal that was so bright and apparently so far away that it was completely unlike anything we'd ever seen before.
Then we realized this is just impossible, unless a civilization is way more advanced than we are.
Scientist Duncan Lorimer and his team had found what we now call fast radio bursts. They're incredibly bright radio signals, so bright that they can't be coming from any naturally occurring phenomena on Earth. They have to be coming from outer space.
Quite frankly, it was unlike anything I'd ever seen before, yet it had all the hallmarks of a signal that was coming from deep space.
I did think that it could be a signal from an extraterrestrial civilization. We create signals like that on Earth, so it's not crazy to think that radio bursts could be created on another planet.
So it was a groundbreaking time for physicists, and with this new data from Lorimer, the burning question everyone still had was, are these alien signals? Now the problem with the Lorimer burst was that it was just a one-off, and how do you prove a one-off is real and not just some noise or some random signal in your detector? Well, it helped when other scientists around the world started detecting signals just like it.
They were coming from all over the sky, and they were clearly real, so it was a breakthrough moment.
Now, although this seemed really exciting, it meant that there were probably much more likely explanations for what was going on.
We observe binary systems of two neutron stars that are in orbit around each other, and when we observe these systems, we see them getting closer and closer together all the time. So what will happen eventually is that they're going to collide. And when they merge, the neutron stars will be completely destroyed and form a black hole. When you look at the energetics of these events, you can easily explain the FRB energies with them. You can also explain the durations of the FRB pulses with the expected durations of these merger events. So it's quite a plausible explanation.
Now, neutron stars are some of the most energetic objects in the universe, second only to black holes, and you need something really energetic to produce a fast radio burst. Now, astronomers recently have discovered a fast radio burst coming from a magnetar in our own Milky Way galaxy. A magnetar is a special type of neutron star that has a very high magnetic field. And while this is really exciting that we finally might have an explanation, it means that aliens producing FRBs is becoming a lot less likely.
Now that fast radio bursts are real, it comes back to the point whether they could be caused by aliens. So if I were looking for a signal from an extraterrestrial civilization, I'd be looking for it coming from a single point in the sky. Here we have a population of sources all over the sky, which implies that the aliens are all over the place, all over the universe. That just seems highly unlikely to me.
So we're one step closer to solving the mystery of fast radio bursts, even though it's looking likely that they're not the alien signals that everyone was secretly hoping for. But as a scientist, I reckon never say never. We'll always keep observing the sky, and I think in our lifetimes, we've got a great chance of discovering alien life somewhere out there in the universe.
We have done a great deal of searching in the last 50 plus years, and we've learned that we're going to have to search perhaps 1 million stars and countless frequency channels before we have a good chance of success. If I had this to do all over, I would still do it. I'd in fact probably put more time into it because I've come to realize that's what's required to succeed. And to me, that time is not time wasted because the eventual discovery is of such importance that it justifies not just one human life being dedicated to succeeding, but many.
This weird creature might just be the best living explorer in the universe.
Took him into space, put him on a satellite, opened up the door, set him outside, exposed him to extreme temperatures, vacuum, right? Hot, cold.
Huge radiation.
And they come back alive.
This is the tardigrade, often called the water bear, and you can probably guess why. And they might even hold clues as to whether life on Earth arrived from outer space.
These creatures are the best candidates to explore whether life came from somewhere else in the universe or it emerged on Earth.
Could they even be the origin of life themselves? So what is a tardigrade? They're aquatic, microscopic animals, barely visible to the naked eye, as they're transparent and only about 1 millimeter long. They also love mossy conditions, which has earned tardigrades their adorable nickname, moss piglets. Aww.
Tardigrade means, this Latin name, slow stepper. Tardi means slow, and grade, it refers to foot. You can start to see he's got long, thin filaments coming off his body, and some actual, more almost look like horns coming off his head that he uses in feeding.
So why are these moss piglets the ultimate space explorers? Well, despite being water-dwelling creatures, they have a special process of morphing or adapting to hostile surroundings, like radiation or freezing temperatures. By drying themselves out, they can cope with all kinds of nasty conditions.
As that sample jar starts to dry out, as that specimen starts to dry out, what's cool about these guys is they can survive that extreme desiccation, drying down to like a crispy little booger.
It's called a ton. They roll up into a special, tight ball, essentially, like a roly-poly bug almost, and then go through a series of radical chemical changes in the cells in their bodies to deal with this loss of water.
Being in a ton form, tardigrades are as far from alive as you can be. But give them a splash of water and they spring back to life. What better place to test the robustness of a ton-state tardigrade than the freezing sprawls of Antarctica?
We extracted them from soils in Antarctica, shipped them back here frozen solid, and they've been frozen solid here at least -60 since 2012. Holy moly! It's mind-blowing, dude. It's basically the same community that I saw when I collected them in Antarctica. We put them in a tube, froze them, shipped them. 4 or 5 years later, we want to study them, right? Pull them out, we thawed them out. And now, what I'm seeing now looks almost exactly like what I saw when I was looking at them, like fresh in Antarctica.
So they can survive the most extreme conditions on Earth. But what about in space? Byron and his colleague Carl took them on a special outing to the International Space Station.
Took them into space, put them on a satellite, opened up the door, set them outside, exposed them to extreme temperatures, vacuum, right? Hot, cold.
Huge radiation. And then when they brought them back to Earth, they did what you're seeing here. They dumped some water on them, see if they actually reanimate.
Voila. they take the water up, man, and they start, right? They swap it out, the molecules, and like a machine, man. You add the water to it, they take them up, cells start to do their thing again, and they come back alive. It always blows my, look, I'm an old fat dude, and I've looked at these 100 times. Thousands of times, millions maybe. Man, well, and then when I actually look at them under the microscope every single time, I'm like, dang, that's cool, man.
Just like that, the mighty water bear enters tun state and navigates brutal conditions that would kill almost every other living thing. So if we know they can survive in space, and we know they survive on Earth, could it be possible that these space explorers travelled between the two, possibly even sparking life on Earth? When the Israeli space agency Space IL crashed their lunar lander Bereshit in April 2019, one scientist began to wonder, could the colony of tardigrades they had on board have survived? And could they survive a crash landing to Earth if they hitched a ride on a meteorite? Alejandro Traspas Muina of the University of Kent set about replicating the Bereshit crash and the kinds of pressures that this little batch of bears would have experienced by firing them out of a gun. Okay, so not quite a gun like that, more of a lab-based gas gun. Alejandro recreated the moon's conditions in a chamber and then fired the tardigrades into sand to recreate the impact that they would have had on that fateful day.
Knowing how fast the spacecraft from the Bereshit mission crashed, we thought, well, let's try different speeds up to 1 kilometer per second, which, if you think about it, if just to get it into a daily activity, just think you're in your car and your car starts going faster and faster and faster, up to 3,600 kilometers per hour. So this is how fast tardigrades were shot. So we started with 0.5, which they all survive, 100% survival, so that's great. We researchers happy, tardigrades happy, and we kept going. We went up to 0.7, and they again survived. Then we went up to 0.9, and unfortunately at these speeds tardigrades couldn't make it, which means they didn't survive the Bereshit mission.
But this isn't the end of tardigrades in space. Alejandro's studies continue. She and her team are testing whether they could survive in the water plumes or the icy surfaces of the moons of Saturn and Jupiter.
These creatures are the best candidates to explore whether life came from somewhere else in the universe or it emerged on Earth. I do not believe life is unique to Earth.
So don't write off tardigrades just yet. They and other extremophiles could still provide the answer to the life we live today. The DART mission is designed to save Earth from an asteroid.
DART is our first planetary defense mission.
Defending against asteroids like this one, Bennu. We're bombarded by almost 50,000 kilograms of space rocks every day. Most are tiny and burn up in the atmosphere as shooting stars. But some bigger ones can cause real damage, like this meteor in Chelyabinsk, Russia in 2013, which exploded with the power of 13 Hiroshima bombs. And that was only 17 meters wide. By comparison, the asteroid that killed the dinosaurs was 10 to 15 kilometers wide. And now, there is another asteroid on its way. Bennu is about 0.5 kilometers wide, about as wide as the Empire State Building is tall. Between the years 2175 and 2199, there is a 1 in 2,700 chance of Bennu impacting Earth. Doesn't sound like much of a risk, but if it does hit, it will have the power of 80,000 Hiroshima bombs. But don't worry, NASA and the European Space Agency are on it. Enter DART, the Double Asteroid Redirection Test. Developed and led for NASA by Johns Hopkins University Applied Physics Laboratory, it does what it says on the tin, really. At least, that's the aim.
DART is a demonstration of the kinetic impact technique, just slamming a spacecraft into the asteroid.
Brilliant.
I'm Lindley Johnson. I am NASA's first ever planetary defense officer. This mission will demonstrate that humankind doesn't have to worry about going the way of the dinosaurs.
Why double?
It is called the double asteroid redirection test because we are targeting a binary asteroid system called Didymos, which means twins, and impacting the moon to change that moon's orbit around the larger asteroid. The impact effects of an asteroid the size of Dimorphos, the moon of Didymos, 160 meters or so in size, the size of a small football stadium, would be an area of a small United States or a European nation. So it's important that we be able to protect life on Earth with this capability.
DART is set to hit Didymos in autumn 2022. We'll be able to measure some of the impact from Earth, but another spacecraft is heading that way. The European Space Agency's Hera will arrive around 4 years later to assess the outcome of DART's mission. But why go to so much trouble when Didymos isn't even at risk of hitting the Earth? Because Didymos isn't the only thing out there. There are over 20,000 asteroids close to the Earth, of which 1,200 are considered high risk. Thankfully, people like Richard Kowalski scour the night sky to find asteroids before they find us. They're known as the asteroid hunters.
As you can see on this screen is the sequence of 4 images that came from the telescope. These objects around the screen are not moving, so we know that they're stars, but this object in the center is moving, and thus we know that it's an asteroid. The importance of surveying for near-Earth asteroids is asteroid impact on the Earth is truly the only natural disaster that we can actually predict before it happens. The Earth has been hit in the past and will be hit again in the future. What we'd like to do is to be able to discover these objects before they hit the Earth.
Observations collected are all sent to the Minor Planet Center, and if they are asteroids that could come near the Earth and be a potential impact hazard, that information is sent to the Planetary Defense Coordination Office at NASA. If an asteroid is a more immediate threat of impact, I actually get a text notification on my smartphone. At NASA, we're kind of the Uber asteroid hunters, maybe is what you could say.
So what would happen if an asteroid did hit Earth? Well, we all know impacts leave craters, but what else happens? Because it's not just the collision itself that would cause devastation.
So for this experiment, we're going to fire this tiny 1/4-inch aluminum sphere at very high speeds, up around 5 kilometers per second. And then we'll see what type of crater it produces. So we use sand because it records the shock effects very clearly.
Pete Schultz uses super high-speed cameras to capture every detail of the impact and aftermath.
High voltage, paddle is in, warning lights, and rolling.
The ball travels 15 times faster than the speed of sound. And like some asteroids would, incinerates on impact.
Oh, perfect, perfect, perfect. Now we're seeing the fireball come in. It's brighter than the sun, and then kapow! It hits the surface, jeez. This whole region downrange would have been incinerated. It would have been incinerated just by this plasma, this exploding vapor plume engulfing everything. There would have been winds that would have been going so fast it could pick up houses and spread them hundreds of kilometers away. This would have been Armageddon.
So all eyes are on the DART mission. And there are a couple of other asteroid deflection ideas floating around too. Some of them are wild. Here are some of the top ones. 1. Nuke it. Very Hollywood, and probably the first thing you thought of too. Great in theory, but could result in radioactive debris raining from the sky. Not ideal. 2. Gravity tractor. Sounds very space farming, doesn't it? The idea here is to fly a device next to an asteroid, so it slowly pulls it away from the Earth's path. This offers a lot of control, but it might not be effective for anything over 500 meters in diameter. 3. Paintballs. Yeah, you heard right, paintballs. Personally, my favorite suggestion. First, the act of shooting the asteroid would deflect it. And also, using white reflective paint means that the force of the sun's photons would theoretically push the asteroid even further off course. The downside? You'd need about 20 years' notice for it to work. So, we've got paintballs, tractors, and nukes, which might all seem like crazy ideas, but they're serious contenders. For now though, it's all eyes on DART and its mission to save the world.